Hey everyone, welcome to the world of data management. This comprehensive course explores the foundation of SQL, empowering you with the ability to interact with relational databases from complex queries and manage data effectively. Additionally, you will delve into the MongoDB, a cutting edge NoSQL database, to master document based data storage and retrieval. Unleash the power of SQL and MongoDB and unlock endless possibilities in the data manipulation and storage. Let's embark on this transformative journey.
There is no business online that would not benefit from using a database, whether you are running a small startup or a billion-dollar company. Not only are they most common and efficient way of storing data, but they also form the foundation of business intelligence and information management today. And if you want to communicate with these databases, you must learn SQL. SQL, or often referred to as SQL by many, is considered as one of the oldest languages in technology domain, which is used to design, build, and maintain database applications tailored to specific needs of the client's business requirements. Some popular and widely used SQL databases are MySQL, Microsoft SQL Server, Oracle Database, and PostgreSQL. SQL developers are high in demand, with companies like Microsoft, Cognizant, Meta, Accenture, IBM, Entity Data, and many other tech giants hiring SQL developers with an average salary of $72,000 and going as high as $100,000 per year. SQL is unquestionably one of the first steps towards a career involving data crunching, and learning it will add great value to your array of skills, which requires little to almost no coding knowledge. Will SQL ever be replaced anytime soon? Well, probably not. SQL is here to stay and will continue to be the go-to query language for many years to come.
First, we will understand who is a SQL developer. SQL developer is a person who is accountable in creating and managing huge data assets of a company. In other terms, SQL developer is a person who can develop SQL databases as well as write and test code. Let's understand this with the help of an example. Let's say we want to search a particular product on Amazon website, and Amazon has stored all its data about products in a database. Now we will write the product name in the search bar, and when we click on the search button, it will run a SQL query that fetches all the information about the product and displays us on the website. So this is the basic task done by a SQL developer. Now we will understand the responsibilities of a SQL developer. All databases have a structure and logic behind how data is stored and retrieved. A SQL developer designs the database accordingly for businesses, that is called database modeling. After the database is created and deployed, it's the SQL developer who is responsible for fixing the general issues of the database. SQL developer should be well versed with structured query language to create optimized SQL queries and refines the existing ones to extract information from the database. SQL developers run several diagnostic tests to keep a check on the server and the database. In order to understand how to organize companies' data, SQL developers must communicate with technical and non-technical persons from the business, and SQL developer also gathers client requirements and identifies the features that the database owners want. As data is an asset to a company, SQL developers backup and restore data for their clients. They also perform tasks like data management and data migration. That is, if a company has stored all its data on a local storage and now it wants its data to be stored in a cloud storage. So the safe transmission of the data from local storage to cloud storage is known as data migration, and that is done by the SQL developers. After knowing the responsibilities, now we should look for skill set required to be a good SQL developer. One should have a good knowledge of SQL commands, functions, joins and procedures. Let's have a look at few commands such as create, drop, alter and truncate. These commands come under data definition language. We also have insert, update and delete commands. These commands come under data manipulation language. We have grant and revoke commands. These commands come under data control language. We also have commit, rollback and save point commands. These come under transaction control language. These are the basic commands a SQL developer should be familiar with. And a SQL developer may have a little command on any one programming language. You don't have to be expert in programming. All you need is how to interface between application and your database. For example, you are using MySQL and your web application is based on PHP, then you should know how to connect your application to the database and how to issue queries, how to fetch results, and then how to display it to the users. One should have a good understanding of various database management systems such as MySQL, Microsoft Access, Oracle, PostgreSQL, DBase, FoxPro, SQLite, IBM DB2, LibreOffice Base, MariaDB, and Microsoft SQL Server. One should know integration of databases with data visualization software such as Power BI and Tableau, which helps businesses to make better decisions and give you an add-on as a SQL developer. One should develop critical thinking and problem-solving skills to create optimized queries. Now we'll see how a SQL developer is compensated in both United States and India. In the United States, SQL developers draw an average salary of $72,282 per annum. In India, the average salary of a SQL developer is Rs 4,49,532. Now we'll see how a person can become a good SQL developer. For that, one should have a good command on structured query language and know how to interact with database management system and can issue queries to get the desired result. Earning industry-recognized SQL developer certifications such as Microsoft Certified Professional Developer (MCPD) or Oracle PL SQL Developer Certified Associate, which usually require a passing score on an exam. And it's important to accumulate as much practical experience as possible. Start by designing, creating, and querying small databases connected with your hobbies and interests. For example, your favorite music, videos, or your personal finances. This will enable you to gain experience, test your knowledge, and build your project portfolio, which will be highly beneficial when you start applying for your first full-time position. Now we will see some major companies recruiting SQL developers. First we have the multinational financial services corporation American Express, followed by the multinational professional services network Ernst & Young. We also have the messaging company WhatsApp. Then we have the e-commerce giant Amazon, as well as the technology and computer solutions company Dell. Finally, in our list of companies, we have the multinational technology company Google.
Have you ever wondered how these big e-commerce companies manage their tons of data that keeps updating every second? And these data sets keep on updating in their databases. To perform operations on this data, they should have a conceptual understanding of these databases. And this is done by understanding ER diagrams of the databases. So let's understand what an ER diagram is. An entity relationship diagram describes the relationship of entities that needs to be stored in a database. ER diagram is mainly a structural design for the database. It is a framework made using specialized symbols to define the relationship between entities. ER diagrams are created based on the three main components: entities, attributes, and relationships. Let's understand the use of ER diagram with the help of a real-world example. Here, a school needs all its student records to be stored digitally, so they approach an IT company to do so. A person from the company will meet the school authorities, note all their requirements, describe them in the form of ER diagram, and get it cross-checked by the school authorities. As the school authorities approve the ER diagram, the database engineers would carry further implementation. Let's have a view of an ER diagram. The following diagram showcases two entities, student and course, and the relationship. The relationship described between student and course is many-to-many, as a course can be opted by several students and a student can opt for more than one course. Here, student is the entity and it possesses the attributes, that is, student ID, student name, and student age. And the course entity has attributes such as course ID and course name. Now we have an understanding of ER diagram. Let us see why it has been so popular. The logical structure of the database provided by ER diagram communicates the landscape of business to different teams in the company, which is eventually needed to support the business. ER diagram is a GUI representation of the logical structure of a database which gives a better understanding of the information to be stored in a database. Database designers can use ER diagrams as a blueprint, which reduces complexity and helps them save time to build databases quickly. ER diagrams helps you identify the entities that exist in a system and the relationships between those entities. After knowing its uses, now we should get familiar with the symbols used in ER diagram. The rectangle symbol represents the entities, oval symbol represents attributes, a rectangle embedded in a rectangle represents a weak entity, a dashed oval represents a derived attribute, a diamond symbol represents a relationship among entities, double oval symbol represents multi-valued attributes. Now we should dive in and learn about the components of ER diagram. There are three main components of ER diagram: entity, attribute, and relationship. Entities have weak entity. Attributes are further classified into key attribute, composite attribute, multi-valued attribute, and derived attribute. Relationships are also classified into one-to-one relationships, one-to-many relationships, many-to-one relationships, and many-to-many relationships. Let's understand these components of ER diagram. Starting with entities. An entity can be either a living or a non-living component. An entity is showcased as a rectangle in an ER diagram. Let's understand this with the help of an ER diagram. Here, both student and course are in rectangular shape and are called entities, and they represent the relationship study in a diamond shape. Let's transition to weak entity. An entity that makes reliance over another entity is called a weak entity. The weak entity is showcased as a double rectangle in ER diagram. In the example below, the school is a strong entity because it has a primary key attribute, school number. Unlike the school, the classroom is a weak entity because it does not have any primary key, and the room number attribute here acts only as a discriminator and not a primary key. Now, let us know about attributes. Attribute. An attribute exhibits the properties of an entity. An attribute is illustrated with an oval shape in an ER diagram. In the example below, student is an entity and the properties of student such as address, age, name, and roll number are called its attributes. Let's see our first classification under attribute, that is key attribute. The key attribute uniquely identifies an entity from an entity set. The text of a key attribute is underlined. In the example below, we have a student entity and it has attributes name, address, roll number, and age. But here, roll number can uniquely identify a student from a set of students. That's why it is termed as a key attribute. Now, we will see composite attribute. An attribute that is composed of several other attributes is known as a composite attribute. An oval showcases the composite attribute, and the composite attribute oval is further connected with other ovals. In the example below, we can see an attribute name, which can have further subparts such as first name, middle name, and last name. These attributes with further classification is known as composite attribute. Now, let's have a look at multi-valued attribute. An attribute that can possess more than one value are called multi-valued attributes. These are represented as double oval shape. In the example below, the student entity has attributes phone number, roll number, name, and age. Out of these attributes, phone number can have more than one entry, and the attribute with more than one value is called multi-valued attribute. Let's see derived attribute. An attribute that can be derived from other attributes of the entity is known as a derived attribute. In the ER diagram, the derived attribute is represented by dashed oval, and in the example below, student entity has both date of birth and age as attributes. Here, age is a derived attribute as it can be derived by subtracting current date from the student date of birth. Now, after knowing attributes, let's understand relationship in ER diagram. A relationship is showcased by the diamond shape in the ER diagram. It depicts the relationship between two entities. In the below example, student, study, course. Here, both student and course are entities and study is the relationship between them. Now, let's go through the type of relationship. First is one-to-one relationship. when a single element of an entity is associated with a single element of another entity. This is called one-to-one relationship. In the example below, we have student and identification card as entities. We can see a student has only one identification card and an identification card is given to one student. It represents a one-to-one relationship. Let's see the second one, one-to-many relationship. When a single element of an entity is associated with more than one element of another entity is called one-to-many relationship. In the below example, a customer can place many orders, but a particular order cannot be placed by many customers. Now, we will have a look at many-to-one relationship. When more than one element of an entity is related to a single element of another entity, it is called many-to-one relationship. For example, students have to opt for a single course, but a course can be opted by a number of students. Let's see many-to-many relationship. When more than one element of an entity is associated with more than one element of another entity is called many-to-many relationship. For example, an employee can be assigned to many projects and many employees can be assigned to a particular project. Now, after having an understanding of ER diagram, let us know the points to keep in mind while creating the ER diagram. First, identify all the entities in the system, embed all the entities in a rectangular shape and label them appropriately. This could be a customer, a manager, an order, an invoice, a schedule, etc. Identify relationships between entities and connect them using a diamond in the middle illustrating the relationship. Do not connect relationships. Connect attributes with entities and label them appropriately, and the attributes should be in oval shape. Assure that each entity only appears a single time, and eradicate any redundant entities or relationships in the ER diagram. Make sure your ER diagram supports all the data provided to design the database. Make effective use of colors to highlight key areas in your diagrams.
How to install MySQL in Ubuntu. But before we begin, if you are an aspiring data analyst, then I have the perfect course for you. We have the Professional Certificate Program in Data Analytics. Boost your career with this data analytics program in partnership with Purdue University and in collaboration with IBM, which features Masterclasses and follows an applied learning model with real-time projects and business case studies. Now that we have a clear understanding of the PGP Data Analytics certification with Simplilearn in collaboration with IBM from Purdue University, we will get started with our tutorial for today's session. So now we're on the Ubuntu operating system. Let's quickly start our terminal. The shortcut key for that is Ctrl-Alt-T. So now we have the terminal opened, so we might have to run a couple of commands. So the first one would be sudo apt upgrade or update. It will ask for the host password. Now you have the update. So usually what happens is when you try with the default method or when you try with the default codes or the commands, you might miss a couple of updates or two or files, right? So what happens when you try with the default codes or default commands is you might miss a file or two. So when you update the Ubuntu, you will get the missing files as well. Now, if you find I've got all the updates, but in case if you find some files are missing, you might receive a message from Ubuntu saying can't update or not fetched, right? In that case, you can try upgrade command. Even then, if you miss a couple of files, there is another similar command which says sudo apt full upgrade. You should also try that as well. So basically what happens is you might have one single command which says sudo apt install MySQL, right? So that particular command will run, but unfortunately sometimes it misses to face complete get. It misses to get all the files. So to avoid that, we will try the brute force method, which will get all the files, all the updates on all the executable files you require to run MySQL in Ubuntu, right? Just a couple of minutes, yes. So similar to upgrade, we have full upgrade. It's done. And in case if you wanted to remove some unnecessary files, you have a command for that as well. So let's take a look at that. So the sudo apt auto remove will remove any of those older packages which you no longer need after the complete full upgrade. Let's run that. There you go. So now we are done with the Ubuntu update. Let's clear the screen by pressing Ctrl plus C shortcut key. The shortcut key Ctrl L has been pressed and the screen has been cleared now. Now we are good to go with our SQL installation command, which is sudo apt get install MySQL. Yeah, so again we face some issues regarding the installation. So this means that we might have some files which we might not need related to MySQL. So my suggestion would be to eliminate those particular files using the sudo apt get remove purge MySQL server, MySQL client, MySQL common, yes. That is why. So we're trying to remove any of the existing files. So let's try to get auto remove and auto clean. Again the update. There you go, we have the update, and now we shall try to install the MySQL server with the following command. But the difference is we are trying to install it with yes, that is -y, providing the permissions. There you go, you can see MySQL is running as PID 6045. Anyways, let's also check the status once the update is done. There you go. Let's quickly check the status by using sudo system control status MySQL. And there you go. It says the server is operational and the main PID is 6240. Let's quickly clear the screen using Ctrl L key combination. And now let's start SQL by using the command sudo MySQL. They should start MySQL for you. There you go. That's how you install MySQL in Ubuntu operating system. Again, you can run all your queries based on MySQL, and in case if you want to quit, just type in quit. So to install SQL Server in Windows, you will need two different software packages. The first one being the SQL Server itself, and the second one is a SQL Server management tool. Let's download these. Let's go back to Google. Now type in SQL Server download. Now you can choose the first option, SQL Server Downloads from Microsoft. Ensure that you are choosing the software from the service provider, which is Microsoft itself, not the third-party software files. Now, if you scroll down, you can see two different versions of the SQL Server. The first one being the developer and the second one being the Express. If you are a learner, then I would recommend you to go with the Express version because it has more features than the developer version and also it is open source. Now let's go with the Express version. Download now. The software file should be downloaded shortly. So the Express exe file has been downloaded successfully. Click on it and it should be running. Now it is asking for the admin permission. Give the admin rights and then you should be good to go. Once you provide the admin rights, the SQL Server installation will begin. So here you can see the window or the dialog box which will give you 3 different options: basic, custom, and download media. I would recommend you to go with the basic version. Select that, and now read all the terms and agreements. Post that, accept, and check the location where the SQL Server is being installed. If you're comfortable with it, you can click on install, or if you want to change, go to browse and select your folder. I'm comfortable with this particular location, which is program files, so I'll click on install. It should be installing in a while. There you go, the download is successful. The installation phase might take a little while. So the download has been successfully done and the installation has also completed successfully. Now only the first phase of the installation process is done, right? The SQL Server is done. But we need another tool, which is SSMS, or SQL Server Management Studio. That you can get right over here. Just click on install SSMB and it will redirect you to a different web page. Just click on the web page you want to go, or the web browser you want to choose. And this is the web page that I was talking about. Scroll a little towards down and you can see the option saying free download for SQL Server Management Studio version 19.0.2. So you might be having the latest versions in the future as well. Let's go with the current version. Click on it. And there you go. The system setup is being downloaded here. It's 629 MB, so it might take a while. There you go. The Microsoft SQL Server Management Studio has already downloaded and is being installed right now. So now you can see there is one bottleneck. You need to restart the system, or you can close and start it anyways. But let's choose the restart option. So after the restart, the SQL Server Management Studio is downloading a few more packages and the installation should be done in a while. There you go, the installation has been complete and you have the Server Management Studio ready to execute. Open that. So here you have the server type, server name, and authentication. If you want to change them, you can, but I'm comfortable with these. And just press connect and you should be good to go and get started with your query editor. Then you can start writing your queries on your SQL Server.
First, let's understand what is MySQL Workbench or MySQL Workbench. So, MySQL Workbench is a graphical tool for working with MySQL servers and databases. You may use the MySQL Workbench for server administration, for creating entity relationship diagrams, and for running SQL queries. MySQL Server is cross-platform, meaning that it can run on a number of different platforms such as Windows, Linux, macOS, and others. Now, we will see the MySQL Workbench functionalities. So first, we have SQL development or SQL development. MySQL Workbench enables you to create and manage connections to database servers. Along with enabling you to configure connection parameters, MySQL Workbench provides the capability to execute SQL queries on the database connections using the built-in SQL editor. Next, we have data modeling. The data modeling functionality of MySQL allows you to create models of your database schema graphically, reverse and forward engineer between a schema and a live database, and edit all aspects of your database using the comprehensive table editor. The table editor provides easy-to-use functionalities for editing tables, columns, indexes, triggers, partitioning, options, inserts, and privileges, routines, as well as views. The third functionality is server administration. It enables you to administer MySQL Server instances by administering users, performing backup and recovery, inspecting audit data, viewing database health, and monitoring the MySQL Server performance. Fourth, we have data migration. Now this functionality of MySQL Workbench allows you to migrate from Microsoft SQL Server, Microsoft Access DB, Sybase, SQLite, SQL Anywhere, PostgreSQL and other relational database management system tables, objects and data to MySQL. Migration also supports migrating from earlier versions of MySQL to the latest releases. And finally, we have MySQL Enterprise support. The MySQL Workbench has support for enterprise products such as MySQL Enterprise Backup, MySQL Firewall, and MySQL Audit. Now, let's have a look at the MySQL Workbench editions available to us. First, we have the Community Edition. So this Workbench edition is open sourced and can be downloaded free of cost. It came under the GPL license and is supported by a huge community of developers. Then we have the Standard Edition of MySQL Workbench. The Standard Edition of MySQL Workbench is the commercial edition that provides the capability to deliver high performance and scalable online transaction processing, that is popularly known as OLTP applications. So the last edition, that is the Enterprise Edition we have, is the Commercial Edition that includes a set of advanced features, management tools and technical support to achieve the highest scalability, security, reliability and uptime. Now this edition also reduces the risk, cost, complexity in the development, deployment and managing MySQL applications. Now with this theoretical knowledge, let's go ahead and see how to download and install MySQL Workbench on Windows. Okay, so I've searched for MySQL download on Google, and let me go ahead and click on the first link, which is from www.mysql.com. This will lead us to the downloads page. I've opened in a new tab, and in the downloads section, if I scroll down, you'll find something called as MySQL Community GPL downloads. This GPL stands for General Public License, which is for free. So we will install the Community Edition of MySQL Workbench. If I click on this, it will take you to another page where you have all the MySQL community downloads, and here you will find something called as MySQL installer for Windows. I'll click on this, and here you can see we have the MySQL installer 8.0 version. Please go ahead and install from this link. You can just click on download. Now we already have a video published on how to install MySQL on Windows, so please click on the above link to know the steps for installation. Let me show you the video. So this is the video I'm talking about, which is already published on our channel, that is install MySQL Server and Workbench on Windows. Alright, now once the installation is complete, go ahead and launch the MySQL Workbench. So here in the search bar, if I just type MySQL, you can see here I have the MySQL Workbench 8.0 version installed. I'll open this. So this is how the interface looks like. It says welcome to MySQL Workbench. It tells you what MySQL is, and here I have already created a MySQL connection. Now let me show you how to create a new connection. I'll just click on this plus button and it will open setup new connection. Now here you can give a connection name. Let me type my name as MySQL _ demo. Now the connection method, you can keep it as standard TCP IP. Now the host name will be the default, port number should be 3306. The username, I have kept it as root because this is what I gave while installing MySQL. Now if you want, you can also set the password. If I click on this, you can enter the password. I'll suggest you to give a strong password. I'll click on OK, and let's try to test the connection. You can see here it says successfully made the MySQL connection. You have the host, the port number, user, and it says a successful MySQL connection was made with the parameters defined with this connection. Just click on OK, and I'll click on OK again. You can see here we have made a new connection which says MySQL demo. I'll click on this and it will open my query editor. So let me open my MySQL Workbench, where we will perform some hands-on demonstrations and look at how to use MySQL functions, write different commands, and we'll see the results. So here on the search bar, I'll type MySQL. So it says MySQL Workbench 8.0 version. Let me open it. Okay, you can see I have a local instance connection. I'll connect to this and I'll enter the password. So this is how my MySQL Workbench interface looks like. Let me just drag this to the top. Okay. Now the white workspace that you see here is called the SQL Visual Editor, and below you will have the result pane and the history output window. I'll show you once I run a query. And on the right hand side you can see we have a help pane or a help window. So if you want to check the documentation or the usage of a certain command, you can just type here and it will give you the documentation. As you can see, I just chose one command, that is select here, and it has returned me the syntax and what select statement really does. Alright, and here on the left side you can see we have something called administration and schemas. These are the different databases that I've already created. So for this demo we will start by creating a new database. So the command I'll write is create database. If I hit tab, it will autocomplete, and the database name I'll give is SQL Workbench. I'll give a semicolon. I'll select this and you see this thunder button. If I click on this, it will execute my query. Okay, you can see here it has returned me one row affected and my query was successful. Alright, now to move inside this database, I'll use the command called use SQL_workbench, which is my database name. Let's run this. You can see we have successfully entered into our database. Now we can create any tables, perform any calculations, operations, data manipulations, retrieve data, fetch data, insert data, and a lot of other operations. Now under the schema, let me just refresh this so that you can see our new database. This is our database. You can see SQL Workbench. Currently we haven't created any tables. If I create a table, it will show here. You can see here views, stored procedures, functions, and other things. So first let's get started by looking at some of the numeric functions that are available in MySQL. So I am giving a comment by typing shift and then my comment, that is numeric functions. First and foremost, we'll see how to use the absolute function in MySQL. So for using the absolute function, I'll write select ABS, and inside this ABS function I'll pass in a value, let's say 22. Now if I run this, it gives me a result that is 22, since the absolute value of 22 is 22, because 22 we have passed in as a positive value. Now let's say I'll pass in minus 22 and let's run it. There you go. You can see here my absolute function has dropped the negative sign and has returned me a positive value, which is 22. You can try for other values. Let's say I'll select minus 50. If I run this, it returns me 50. Alright. Next, we'll see how the mod function works. So the mod function returns the remainder of a division. So if I write select mod and I want to divide 10 by 4. Let's run this and see the result. You can see it has returned me 2, because the remainder for 10 divided by 4 is 2. You can also give an alias name to this. I'll write as remainder. The reason why I'm giving an alias name is because the result we have got, if you see the column, this is not very readable. Now if I run this, you can see the difference. There you go. Now the output is much readable than the previous one. Okay, so let's say I want to find the mod of another division, 15, 3. as remainder again. I'll run it again. You can see 15 divided by 3, the remainder is 0. Let's try for one more. Let's say 50.6 divided by 2. You can already guess the result. It should be 0.6. There you go. You can see this is my remainder. Now, as I said, the below window is called the history output window or the pane, and this is called the query result pane, which is part of the MySQL workbench. Let me just drag this a bit. Okay. Now moving on to the next numeric function, we will explore the power function. Now suppose I write select power 4 raised to 2. Let's see the result. I'll run it. It gives me 16, which is correct. Let's see. I'll write select power 10 raised to 3. You can already think of the result. It should be 1000. Okay. Now, like how you use the power function, similarly you can use the square root function. In MySQL, the square root function is written as sqrt. So you can get the square root of a number by using the sqrt function. Let's say I want to find the square root of 4. If I run this, it gives me 2, which is the square root of 4. I'll edit here itself. Let's say I want to find the square root of 144. If I run this, it gives me 12, which is the square root of 144. Now moving ahead, let's say you want to find the greatest number within a range of numbers. You can use the greatest function that is available in MySQL. I'll write select greatest. I'll give a range of numbers. Let's say 2, 5, 18, 6, and let's say 12. I'll give a semicolon and let me run it. It returns me 18 because 18 is the largest or the greatest number in my range of numbers. Similarly, you can also find the least number. For that, you can use the least function. This will return me the minimum number present in my range of numbers. In this case, it is 2. Alright. There's another function that is available in MySQL is truncate. So the truncate function truncates a number to the specified number of decimal places. So suppose I write select truncate 22.897, 1. Let's see the output. Okay, you can see here. So the truncate function has returned us 22.8 and it has truncated the rest of the decimal places. I want to truncate up to 2 decimal places. Let's see the result again. You can see here it has given us 22.89. Next, we have another function called round. So the round function in MySQL is used to round a number to a specified number of decimal places. If no specified number of decimal places is provided to roundoff function, the roundoff function rounds the number to the nearest integer. So let's see a few examples. Suppose I want to round the value 22.897. This time I am not passing the specified number of decimal places. We'll see the result. It has returned me 23, which is the next highest integer. Suppose you want to round it to 2 decimal places. You can give a comma and then say 2. I'll run it. It has given us 22.90. So this 89 it has converted to 90. Similarly, if you want to round the number to 1 decimal place, it will give you 22.9. Alright. Now, let's create a students table and store it in our MySQL workbench. So I'll just give a comment called student table or students table. Alright, so the way to create a table in a database in MySQL workbench is you write create table followed by the table name that you want. In this case I'm going to create a students table. Then you start with parenthesis and give the columns that you want in your table. So first I want the student ID. You can think of this as the student roll number. Give a space and then give the data type of the column. Now student ID should ideally be of type integer. I'm assigning this as primary key. So the primary key will uniquely identify each record in a table and it cannot have any duplicate values. So ideally, if you think, all the students in a school will have a unique roll number. No two students will have the same roll number. Next column I want is the student name. Now the name is of type varchar and I'll give the length as, let's say, 25. Then I want the age of the student. Age is also of type integer and I'll write in the same line. Then I need the gender. Gender of the student should be of type character and the size I'll give as 1. Then we have DOA, which stands for date of admission and it is of type date. Then we have the city to which the student belongs to. Then city is also of type varchar. Alright, you close the bracket and give a semicolon. Let's run this. There you go. Here you can see in the history window it says the table was created successfully. Now let's just refresh this again so that you can see the table. Here under MySQL Workbench database, under tables, you can see we have a students table. Let me expand this further so that you can see the columns that we have. There you go. We have the student ID, the student name, age, gender, date of admission and the city. Okay. Now it's time to insert a few records to this table. For that you need to write the insert statement. Now I'm going to open a notepad where I have already written the insert statement. So let me just copy paste it here. Okay, so here on my notepad I have my insert statement already written. I'll just copy this and I'll paste it on my workspace. Okay, if I go to the top, you can see this is how my insert into command look like. You have insert into followed by the table name, which is students. Then you have the values keyword and we have the set of records. So the first value represents the student ID or the roll number. Then you have the student's name, you have the age, you have the gender, then we have the date of admission, and then we have the city to which the student belongs to. Alright. Now let me go ahead and run my insert query. I'll just select everything and I'll hit on execute. You can see here we have successfully inserted 20 rows of information to our table. Now if you want to check all the records in a table, the SQL command is select star from table name, that is students. If I run this, this is my output. You can see we have the student ID, the student name, age, gender, date of admission and city. If I scroll down, there are total 20 rows of information in my table. Now the star represents you want to select all the columns in the students table. Suppose you want to return specific columns from the table, you can mention that in the select statement itself. Suppose I want to select the student name, the age of the student and the city to which the student belongs to. So I will write select stu underscore name, which is my column name, comma the age, comma the city from my table name, that is students. Let's run it. you can see the output. We have only 3 columns displayed in the result. Okay, now let's see how to use the where clause in SQL or MySQL. So the where clause helps you filter specific records based on certain condition or conditions. Suppose I want to see the students who are from Pune. So I want to display only the records of students who are from Pune city. So the way to do is I'll write select star from students where city equal to Pune. Now this Pune is a character type, so you need to mention it within single quotes. Let's run it. There you go. In the output you can see there are total 4 students who are from Pune. You have Joseph, Anubhav, Akshay and Anand. Alright. Now let's say you want to filter only those students who are from Miami and their gender is male. Again, you are going to use the where clause, and along with the where clause we will use the AND operator. So I'll write select star from students where city equal to, I'll say Miami. This Miami should be within quotes. I'll use my AND operator and then write the gender should be equal to M or male. Again, M should be within single quotes. I'll give a semicolon and let's run it. You can see here we have Vipul, Ishan, Tanishq and Amrit who are from Miami city and their gender is male. Cool. Now moving ahead, suppose you want to know the students who are either from city Boston or Chicago. In that case, you are going to use an OR operator. I'll just copy this SQL command and I'll paste it here and I'll edit in the same query. So this time we want the students who are from city Boston or Chicago. So here instead of Miami I'll write Boston. I'll use an OR clause or an OR operator, and instead of gender equal to male I'll again write or city equal to Chicago. Let us run the SQL query and see what we have. So there are total 6 students who are either from city Chicago or from Boston. We also have a female student, Eliana. Alright. Now moving further, let's say you want to display the records of the students who belong to any city rather than Chicago. In that case, you are going to use the NOT operator. So I'll write select star from students where not city equal to Chicago. Let's run it and see the result. Alright, you can see total we have returned 17 rows of information, which means there are total 17 students who belong to other cities apart from Chicago. If you see the result, you won't find any student who is from Chicago city. Okay. Now there's another important feature of MySQL where you can group certain rows of information based on a particular column or columns. So let's see how to use group by in MySQL. I'll give a comment called group by. Now in this group by clause, we are going to find the total number of students present in each city. So the way to do is I'll write select. I want to select this city and then I'm going to use the count function. This is an inbuilt MySQL function. I'm going to count the student IDs. I'll give an alias as total students from my table, that is students. Then I'm going to group my result based on each city. Let's run this and see the output. There you go. You can see here. So our table has total 6 cities. You have Pune, New York, Miami, Chicago, Detroit and Boston. And here on the right hand side you have the total students that we just created using an alias name, and this total students column has the total number of students from each city. So if you see here, New York has 4 students, Pune has 4 students, in Miami, Chicago we have 4 and 3 students, and in Detroit we have 2 students respectively. Alright, the next clause we are going to see is having. Now having and where are kind of similar, but there are certain differences. Now for our example, we are going to find the cities where the total number of students are more than 3. If you see the results pane, so we have Pune, we have New York and Miami as the cities where there are more than 3 students. So let me show you how to return these 3 records. So I'll write select city, comma, I'll count the students using the count function, and I'll pass my column as student ID, and I'll give an alias as total students from my table, that is students. I'll use the group by clause, group by city, and then I'm going to use having the count of student ID greater than 3. Let me run it and show you the result. There you go. As expected, we have Pune, New York and Miami where the total number of students are more than 3. Let's see how the order by clause works. So the order by clause is used to filter the records based on a particular order in ascending or descending order. So suppose, see, I write select star from students, and then I'll write order by, let's say, city. Let me show you the result first. Okay, you can see the city column has been ordered in alphabetical order. So first the cities start with B, then we have C, D, M, and then we have N and P. What if I want to order the result in descending order? So again it will alphabetically sort my result in descending order of city. So on the top we have Pune, because alphabetically in descending order Pune starts with P, so it appears on the top. Then we have New York, followed by Miami, Detroit, Chicago and Boston. Now it's time to explore some string functions in MySQL. So I have given a comment, string functions. First, let's say you want to convert a certain string into uppercase. So I can write select. The function I'll use is upper, and within this function you can pass in the string. Let's say I'll write India. If you want, you can give an alias name as, let's say, uppercase. I'll give a semicolon and let's run it. There you go. So my input was in sentence case, and using the upper function we have converted everything into uppercase. Similarly, let me just copy this and I'll show you. If you want to convert a string into a lowercase, you can use the lower function. I'll run this. You can see the result. Everything is in lowercase now. Of course, I need to change the alias name to lowercase. Now, instead of using lower as the function, there is another function that MySQL provides, which is called the L case. So I'll just edit this and write L case, and let's say I'll write India in uppercase. Let's run it. It returns me the same result. Cool. Now moving on, let's say you want to find the length of a string. You can use the character length function. I'll write select, use the function character length, and I'm again going to pass in my string as India as, let's say, total length. Let's run it. This time I'm going to hit Control Enter to run my SQL command. There you go. It has given us the right result, which is 5, because India has 5 characters in it. Now these functions you can also apply on a table. Now let me show you how to do it. Let's say we already have the students table and you want to find the length of each of the student names. So here you can pass stu_name and you can give the same alias name, let's say total length, and then you can write from table name, that is students. If I run this, you can see the output. It has given me total 20 rows of information. It is not readable actually. Let me also display the student names so that we can compare their length. Alright, I'll run this again and now you can see the result. So Joseph has 6 characters, Nilesh has 6, Vipul has 5, Anubhav has 7. Similarly, if you see, Akshay has 6, Tanishq has 7, Raghav has 6, Cummins has 7, Rabada has 6, so on and so forth. Now instead of using this character length, you can also use the function char length. It will work the same way. Let's see the result. There you go. It has given us the same result. You can either use character length or char length. Now there's another very interesting function called concat. So the concat function adds 2 or more expressions together. Let's say I'll write select. I'll use the function concatenate. The function is actually concat, and I'm going to pass in my string values. Let's say India is in Asia. Let's run this and see our result. You can see here it has concatenated everything. Let us make it more readable. I'll give a space in between so that you can read it clearly. Now this is much more readable. India is in Asia, and if you want you can give an alias name as well, as let's say merged. There you go. Now the same concat operation you can also perform on a table. I'm going to use the same students table. Let's say I want to return the student ID followed by the student name, and then I am going to merge the student name followed by a space followed by the age of the student, and I can give an alias as, let's say, name_age from my table, that is students. Let's see how this works. Okay, you see here the result is very clear. We have the student ID, the student name, and the concatenated column that we created, which was name_age, where we have the student name with a space followed by the age of the student. If I scroll down, you can see the rest of the results. Cool. Now moving ahead, let's see how the reverse function works in MySQL. So the MySQL reverse function returns a string with the characters printed in reverse order. So suppose I write select reverse. I'll use the same string again. Let's say I have India. Let's run it. You will see all the characters printed in reverse order. Again, you can perform the same operation on a table as well. Let's say I'll write select reverse and I'll pass in the column as student name from my table, that is students. Let's run it. It gives you 20 students and all the names have been printed in reverse order. Okay. Now let's see what the replace function does. So the replace function replaces all occurrences of a substring within a string within a new substring. So let me show you what I mean. I'll write select replace. I'll pass in my input string, which is, let's say orange is a vegetable, which is ideally incorrect. I'm purposely writing this so that I can replace the word vegetable with fruit. Okay, so what this replace function does is it is going to find where my word vegetable is within the string, my input string, and it is going to replace my word vegetable with fruit. Let's run it and see the output. There you go. Now this is correct, which is orange is a fruit. Alright. Now MySQL also provides some trim functions. You can use the left trim, right trim, and just the trim function. So let me show you how this left trim works. Left trim or L trim removes the leading space characters from a string passed as an argument. So say I write select, I'll use the left trim function, which is L trim, and then I'm going to purposely give a few spaces in the beginning of the string. I'll give a word, let's say India, and then I'll give some space after the word India, and see how the L trim works. If I run this, it gives me India, which is fair enough. But before that, let's first find the length of my string. So I'll use my length function here, and within this function I am going to find the length of my string, which has India along with some leading and trailing spaces. I'll paste this here, give a semicolon, and I'll run it. Okay, so the entire string is 17 characters long, or the length of the string is 17. Now say I use ltrim on my same string, what it returns me is India, and if I run length over it, you can see the difference, as in you can see how many spaces were deleted from the left of the string. You can see here, now it says 17, and I'm going to use ltrim. Let's see the difference. It gives me 12. The reason being it has deleted 5 spaces from the left. You can count it, 1, 2, 3, 4 and 5. So 17 minus 5 is 12, which is correct. Similarly, you can use the rtrim function, which removes the trailing spaces from a string. Trailing spaces are these spaces. When you use left trim, it deletes the leading spaces, which is this. Now let me just replace ltrim with rtrim, which stands for right trim, and see the result. So the length is 10 now. The reason being it has deleted 7 spaces from the right of the string. If you can count it, 1, 2, 3, 4, 5, 6 and 7. Cool. You can also use the trim function, which will delete both the leading and the trailing spaces. So here if I just write trim and I'll run it, it gives me 5 because India is total 5 characters long and it has deleted all the leading and the trailing spaces. Alright. There's also a function called position in MySQL. The position function returns the position of the first occurrence of a substring in a string. So if the substring is not found with the original string, the function will return 0. So let's say I'll write select position. I want to find where fruit is in my string, that is orange is a fruit. I'll give an alias as name. There's some error here. This should be within double quotes. Now let's run it and see the result. Okay, it says at the 13th place or at the 13th position we have the word fruit in our string, which is orange is a fruit. Now the final function we are going to see is called ASCII. So the ASCII function returns the ASCII value for a specific character. Let's say I write select ASCII of the letter small a. If I run this, it will give me the ASCII value, which is 97. Let's say you want to find the ASCII value of 4. Let's see the result. It gives me 52. Alright. So that brings us to the end of the demo session on MySQL Workbench. Let me go to the top and show you the things that we covered. So first of all, we created a new database called MySQL Workbench, which you could see it here under schemas. There was a database created called MySQL Workbench. Then we entered into the database using the command use MySQL Workbench or SQL Workbench. We explored a few numeric functions where we saw how to use absolute, mod, power, square root, least, greatest, truncate, round, and then we created a table called students. We inserted some 20 rows of information of different students and their age, date of admission, city. We saw how to use where clause, how to use the and or operator. We used group by to group our records based on certain conditions. We also used having, we used order by, and then we look at a few string functions such as lower, upper, concat, character length, reverse, replace, ASCII, and position. Alright.
If you're an aspiring data engineer looking for online training and certifications from the prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM should be your right choice. For more details, use the link in the description box below. So, what exactly are temp tables in SQL? So, temp table is a temporary table. So the term temporary is self-explanatory. You know that every database in SQL has tables, right? Now let's say you created 10 tables in your database and you close your MySQL Workbench or you close your database and you restart it after a while, and then you will have all your 10 tables intact in your database. But temporary table is not like that. It is something different which has its existence until the session of the database is running. Let's say you open the database now, you have this session of the database running, you created the 11th table as a temporary table, and that particular 11th temporary table will be existing in the database only until the current database is running and active. Once you close it, once you turn it off, or once you restart it, the temporary 11th table that you created will die or it will be eliminated. So that is the meaning of temp table. Now let's see how we can create a temporary table. So the syntax is completely similar to the temporary or to the table what we usually create, right? It is similar to the table what we regularly create, but the only catch is we will be using the keyword temporary. create temporary table name which is user defined name, and inside that the parameters may be the employee ID, student ID, employee name, student ID name, etc. Right? So this is how we create the temporary table. Now let's quickly get back to the SQL workbench and try to create a temporary table, add some data into it, and try to display the temporary table.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are back on the SQL workbench, and meanwhile we are logging in. You might have a question, right? When you say that the temp table will be existing or running only until the database is active, then why create those temporary tables in the workbench, right? The sole purpose of using temporary tables is, in a few cases, the intermediate results of the data analytics process are important, and you can have a quick reference on the intermediate results, and you don't want them to be existing in your database in a permanent basis, right? For such scenarios, you can use a temporary database. Now here on my workbench, we have a simple code for creating a temporary table. So I'll be creating the temporary table on the name of student, and we have student ID, integer data type, student name, worker, and department, and student ID will be the primary key. Now let's use the database, that is use Simplilearn database to get access, and we have the access now. Let's quickly see what and all tables we have using the show command. Show tables, enter, and we have two tables, employee and employee table 2, but not student. Right, now let's quickly execute this, control enter, and now let's use the insert command, same like we inserted in the previous tables. Insert into table name student, parameters ID, name, department, and values, comma separated values, student ID, name, and department or group, whatever he took in college. Right, now let's execute this code, control enter. There you go, the data has been successfully included. Now let's select star from student, that is view the contents in this particular table. We have the values in this particular table, and let's also see if we have that particular data included in the database or not. That is show tables. There you go, it's not included in the database, but it is active. When you try to print the values in that particular table which is in the database, it will show you, but when you try to fetch that particular existence or the permanent existence of that particular table, it will not be present, and this particular table will be active only until the database is active. Now let's restart this particular workbench. I'm closing it, restarting it. Now if I run this, I will not get it. You can see the error, the database, right? Okay, let's have the database selected, and let's try to run the command. There you go, table Simplilearn db dot student does not exist, right? Previously when you try to execute, the table was giving us values. Now we have the error saying the table does not exist, right? That is how a temporary database runs. SQL. So first let's have a quick look on the syntax we use to create a database. So first we have a create keyword which will explain the SQL server that we are trying to create a new element, which can be a database or a table. Next we have the keyword database, which clarifies the SQL that we are trying to create a new database. The next one is not mandatory if not exists, just we are trying to make sure that the database that we are going to create is not already existing. So if you use this if not exist, then SQL will tell you in case if there is an existing database on the same database name, then it will not allow you to create a duplicated database. And followed by that, we have the database name, which can be anything. So I've just created as database name here. Now that we are clear with the syntax, let's get back to the IDE, that is MySQL, to execute a command to create a new database. So now we are on the SQL workbench. Now let's quickly try to log in. There you go. Now you can see some existing databases on the left hand side of the workbench. SYS or system is the default one. So I already created test and trial. Let's try to create a new one right away. So the create keyword and database keyword, and then if not exists. So here you can see I'm trying to capitalize the keywords so that it's easier to understand what is the code and what is the user defined names, right? So create database if not exists and Simplilearn DB. That's our code. Let's try to execute this, and there you go. So here you can see in the action output, create database if not exists, Simplilearn DB has been executed successfully. Now we can run a new code which says show databases This should show us the newly created database, which is Simplilearn DB, which is right over here. So that's how you create a new database in SQL. Now the syntax is as follows. Now here you have the insert and into keywords. Table name is the user-defined name for the table. Then you have the columns, that is column number 1, 2, and etc. Then after declaring the column names, you have the keyword values, which will help SQL understand this is a tuple and these are the values involved inside the tuple. That is row 1 value 1, row 1 value 2, so on, and row 1 value n. So this type of syntax will help you to add one tuple at one time, and this will take a lot of time to process. You can see to insert the next tuple, we are writing a completely new syntax once again, using the same insert into table name, column 1, 2, 3, n, values, and row number 2, that is the second tuple. Right. So this type of code will take longer duration to run, as well as it will take longer lines, or number of lines will be extra. So is there a way where you can add multiple tuples in one single go? Yes, there is. So the syntax will be completely same. Right. So you will be using one insert into keyword, one table name, and once you will be declaring all the column numbers, and once you will be using the values keyword. The only difference is you will be adding multiple tuples under the values bracket. Right. You will be declaring the number of values you want to include in one single go, and this whole query becomes as a whole. And once you run this query, all the values will be added at once. Now that you are clear with the syntax, let's quickly get back to the SQL workbench and try to run this command. Now we are on the MySQL workbench. Let's quickly log in. There you go. We have logged in. Let's use the Simplilearn database once again so that we get access to the data which we have. So we already have an employees table. So let's see what's presently included in employees table. Select star from employee table semicolon. So this is the data that we already have in our table. Now let's try to add some more data. So now we will include one single element or one single tuple, data related to one single employee, right, using the first type of syntax. Let's quickly execute this. The command got executed. Again, let's quickly see what's present in the table. Select star from employee table. Again, you can see I'm using lowercase for the user-defined keywords and uppercase for the predefined keywords, just to make sure that the code is understandable and which is the user-defined keyword and which is the predefined keyword. So these are the ones in small case are user-defined and the ones in uppercase are predefined. Right, so we have successfully included one single element or one single tuple, the details which are related to Brian. And now let's try to modify the same code and try to include few more tuples inside the same insert command and try to insert multiple rows into the table. Now here you can see we are using the same insert into employee table command, and instead of Brian, we replaced or we added 6 more entries under the values section, right? And the only difference is we are trying to separate the tuples using a comma. You can see we are enclosing one tuple inside the parenthesis and we are separating 2 tuples with the help of a comma. Right, ensure that you include comma between every tuple and you can ignore the comma for the last tuple. You can see we are not using any sort of comma or any sort of specifier at the end, right? So, and we are closing the command using the semicolon. This explains SQL that it is the end. Now we are going to run this command and see the output. So there you go, the command got successfully executed. Now let's again execute the select command and see if the data is involved or included or inserted into the given employee table. Now there you go, the command got successfully executed and you can see the table over here and you can see that all the data or all the tuples we included into the table using the insert command in one go are successfully included. So that's how you insert multiple rows into a table using SQL. So how to update table in SQL. Let's quickly take a look on the syntax for today's function. So here we have the update keyword, table keyword, and the table name which you want to update. And followed by that, we have the set keyword, which will help the SQL to set a particular column name to a new parameter to which you want to update it. Now you're giving a where condition over here. So where is the keyword and the condition is a user-defined condition, and the combination of where and condition will help SQL to identify a particular tuple and update the parameter under that particular condition. Now that we have understood the syntax, let's quickly get back to the SQL IDE, which is MySQL workbench, and try to execute a sample command. So we are on the IDE and previously we tried to create an employee table. So let's select the same table. For that, let's use the database we created, that is Simplilearn DB, semicolon, enter. So we are on the Simplilearn database now. To update a table, we need to have some data in it. So as we remember, we just tried to create a normal table in the previous session. Now let's try to add some data into the same table using the insert command. So let's try to make use of the insert command. And insert into is the keyword, employee table is the table name, and these are the columns we have in the employee table. And followed by that, we have the values keyword, and followed by that we have the data which we need to enter into the table. And these items are in the form of a tuple, and every tuple is covered using parentheses. And inside the tuples you have the first one, which is an integer type data, which is as it is, and when you come into the text type data, they are covered using the single quotes. So let SQL identify that it is a character type data. Now after entering all the tuples separated by comma, we have a semicolon which indicates the end of the statement. Now let's try to run this particular statement and add the data into the employee table. So let's select the database once again, and now let's try to add the data. There you go. Now we have the data added onto our employee table. Let's quickly check the employee table. Select star from employee table. There you go. We have all the data added onto the table: employee ID, employee name, and employee address. Let's say the last employee, Jeremy, who's been working in Delhi since a past couple of years, and you decide, being the manager, you decide that he should be relocating to Hyderabad. And you need to update the employee table now by changing the location of Jeremy from Delhi to Hyderabad. Now let's try to run our update query. So first we have the update keyword, then employee table, then set emp address equals to Hyderabad, where condition emp id equals to 1006 and semicolon. So there you go, the code is complete. We have the update keyword followed by the table name, then set keyword to set that particular column, that is the employee address, to the key Hyderabad. From Delhi, we are changing it to the Hyderabad, which is value or key value, whichever you consider. And since it is a text type value, we are encoding it using the single quotes. Then the where clause and the condition, which is employee ID must be equals to 1006. Now let's try to quickly run this command. There you go. Now let's recheck if the table has been updated or not. So select star from employee table. Let's run it. And there you go. The last location, Jeremy, which was Delhi, is now updated to Hyderabad. So that's how you update values in a table. Now you might be having multiple questions. Is adding a date, is that tough in SQL tables? No. You can add a date in SQL in the format of varchar or character, everything. But if you want to perform analytics, then using the date format or date data type would be more beneficial, right? So for the SQL table, you do have some formats to follow. So that's exactly what we are going to discuss in this particular tutorial. Now let us imagine that we are going to create a table using the following syntax, that is create table keywords, table name, which is a user defined table name, and the parameters, their respective data types, and at the end, let's say we have a date element as date of joining, and for date of joining we will have the data type as date, right? Then let's see the code. And you need to make sure that when you're trying to enter the date element into your table, you need to be a little more cautious to follow a pattern. SQL has predefined approach to store dates, which is in the format of YY, year, MM for month, DD for dates. You need to follow this particular way of writing your date, and if you make some minor error, let's say you added date first, then the month, and then the year, then obviously SQL will throw an error. So we don't want that to be happening. So in that case, let's try to follow the approach that SQL has. Now let's quickly go back to SQL Workbench and see how exactly it works. So here we are back on the SQL Workbench. Let's run this use database command to get access to our database. There we go. Now let's see, we have a freshly created database and it doesn't have anything, right? Now we will add these particular details into the data table, and here you see we are following the year, month and date approach, right? Now let's quickly run this command, and there you go, the date has been updated into the table. Let's now run the command again. Now we have the dates here. Now let's say we try to break the rules. Now we will try the DD, MM and the YY format here. Right, now let's try to run this particular code once again. Okay, let's eliminate all the previous elements and let's consider this as a new entry. Right, now let's try to execute this. There you go. So it will automatically throw an error saying the date value is incorrect. You need to change it back to the original form, that is YY, month and the date. Only then it will accept this particular value. There you go. So that's how you add date to your SQL tables. Let's quickly take a look at the syntax that we will be using today. So we will be using the alter keyword and the table keyword. Followed by that, we will be specifying the table name in which we want to add a new column. Then we have the add keyword and name the column which you want to add to your existing table. Then the data type of that particular column with constraints if you have any. Now that we're clear with the syntax, let's get back to the SQL Workbench where we can execute this particular command. Now we are on the SQL Workbench and let us execute this particular command and see what we have in our existing table. Okay, I think we might have to use this particular command first. You need to get the access to your database, then you can get access to your tables in your database. Right, so we have this particular data. Let's try to add a new column which explains about the phone number of a employee working in your organization. Okay, now we can use this particular command, which is alter table. There you go. So we have added the column phone number, data type, and the constraint, not null. And if anything is not added in that particular column, the default value should be NA. Right. Let's quickly execute this particular command. There you go. Now let's check if the new column is added or not by running the select command. There you go. The new phone number has been successfully added, and by default, since we did not add any number, we have NA in that particular column. So that's how you add a new column to your existing table in SQL. How to change the column name in SQL. So let's quickly take a look at the syntax that we will be following to change the column name in SQL. So the syntax is as follows. We will be using the alter and table keywords, and we will be specifying the table name, and then we will give the rename column keyword, then the old existing column name, and to the new column name which we need to change it to. So having a clear understanding of the syntax, let's try to execute this command in the practical mode. So let's get back to the MySQL workbench. So now we are on the MySQL workbench. Let's quickly get access to the Simplilearn database. There you go. And now let's quickly take a look at the column names in our existing table. Now you can see the first column is the employee number. Let's try to change that by using the alter table command, and now the rename keyword. The column name is emp number to emp id semicolon. Let's quickly execute this command, and there you go. Now let's try to execute the select command once again and see the output. There you go. Now the employee number has been changed to employee ID. So that's how you change the column name in SQL. How to change the data type of a column in SQL. Now let's take a quick look on the syntax we will be using to change the data type of the column in SQL. So this is the syntax we'll be using. So we will be using the alter keyword, table keyword, and table name. So alter is the keyword which will help SQL to understand that we are trying to modify something, and we are selecting the table by offering the table name. And then we have the modify keyword which will help SQL to understand that we are trying to modify something, and we are modifying the column name from the table selected, and we are modifying that particular column to a different data type which will be specified over here in place of data type keyword, right? So now that we are clear with the syntax, let's proceed and execute the command and change some column data types. Now we are on the SQL workbench. Previously, we created an employee database in Simplilearn DB, and we will be using the same table here. So we will be typing use Simplilearn DB so that we get access to the Simplilearn DB and the tables we have there. So let's select all employee table, column. Let's execute this. So there you go. We have the table on our screen. And let's quickly describe the table using the desc command. And this will give us the data types of each and every column in our table. Now you can see we have pin code in the format of worker. So let's try to alter or modify this particular pin code column from worker to integer, since it only saves the numbers, right? So our command for that was alter table name, which is employee table. Modify was the keyword. Modify the column pin code to integer semicolon. Now let's quickly run this command. And there you go, the command got executed successfully. Let's try to describe the table once again. And there you go. Now the pin code was earlier mentioned as worker, and now it got changed to integer. Now that's how you alter or modify or change the data type of a column in a table in SQL. Now let's quickly take a look at the syntax that we will be following to execute this particular command. The syntax is as follows. We will be using the alter table keyword, then the table name where we want to eliminate the column, followed by that the drop column keyword and the column name. Now let's get back to the SQL workbench to execute this particular command. Now we are on the SQL workbench, and you can see we have 5 different columns over here, and we have the phone number column which does not have anything. Now we will try to eliminate this particular phone number column since we do not need that for our purposes. Now the command is really simple. As discussed before, we will be using the alter table keyword and the table name, and the drop column keyword and the phone number, which is the column name. Now let's quickly execute this particular command and see the output. There you go. Now the column phone number has been successfully eliminated. Now let's run the select command once again and see the new table. There you go. The phone number column has been successfully eliminated. Now with that, we have come to an end of this session on how to eliminate a selected column in an existing table in SQL. How do you delete a row in SQL? Let's quickly take a look at the syntax. So we will be using the delete keyword and the from keyword, adding the table name and giving a where clause with a user-defined condition. So this will be a basic syntax for the process of deleting a single row in the SQL table. Now to understand in a much better way, let's get back to the SQL workbench. So now we are on the SQL workbench, and previously we tried to create a table, add some data using the insert command, and update a value using the update command. Now let's say we have to delete the last row, which is 1006 Jeremy Hyderabad. Let's say Jeremy found a new job in a new organization, and now you need to eliminate his credentials from your database. So we will be using the following code. That is delete from table name is employee table, and the where clause. Now the condition, which is EMP ID is equals to 1006. Now let's try to run the code. There you go. The employee is being eliminated from that particular database. Now let's try to recheck the table. So select star from EMP LOYEE table. Run the code, and there you go. The last ID, which was 1006, has been eliminated from your database. And that's how you delete a row in SQL. That is how to print or how to obtain current date in SQL. Now the syntax is really simple. We have 2 different commands to do that. We can just type in select get date, or we can just type in select current date or CUR date. So these particular commands or functions will fetch us the current date in SQL. Now to execute these commands, let's get back to the practical mode, which can be a SQL workbench. So now we are on the SQL workbench. Let's log in. There you go. So we have both the commands. Let's try to execute them. Control Enter, and there you go. So we have the current date. So that's how you can fetch current date using getDate function or the current date function in SQL. Let's try to take a quick look on the syntax that we will be using today. Right? It is simply the select star from table name using the where clause and the column which you're choosing for that, and the between operator, and we are giving some constraints, and those different constraints are encapsulated between an and command here. Let us say that your manager tells you to select all the rows where selecting one single column, that is salary, where the employees have the salary from 10,000 to 20,000, right? Then you will write the command select star from table name where salary between the value 10,000 and the value 20,000. So this is how the between command works. Now let's execute the same practically. Let's get back to the MySQL workbench.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are back on the MySQL workbench. Let's make some edits to the same command. Select star from employee where salary between operator. So we are using float or integer type, so we will not need the single quotes or double quotes. Number 10,000 and operator number 20,000. Right? Now let's execute this command. There you go. Now we have all the employee list which have or who have their salary ranging from 10,000 to 20,000. Now we can eliminate the duplicate records in SQL by a few methods. So we will use the most simplest ones. The first one is using the inner join along with a where clause, and the second one is a simple and the humble distinct command. Now we have a brief idea on the methods. Let's understand them in a much more detailed way through a practical demonstration. Now let's get back to the MySQL workbench to understand the codes in a much better way. So now we are on the MySQL workbench and we will get access to our Simplilearn database, and we are in the Simplilearn database. So previously we used to work on our employee table. So let's not work on the same employee table since we have actual data there. Let's try to duplicate that table so that we will have some duplicate entries in between. So we will be changing the employee ID numbers, and we will also be using the same employee ID numbers. So the employee ID has some detail to it. So we'll be understanding that in a much more detail while we are executing the commands. And we will also try to remove the primary key from the table. So I'll also explain why we are going to include the primary table, and also will explain the usage of eliminating it. So when you have the primary key in the table, SQL workbench or any SQL will automatically stop you from adding duplicated values. But let's say if you add a duplicate entry with a new primary key, right, then it will not stop you. So we'll also have a demonstration about what to do in such scenarios. So now let's try to quickly create a duplicate employee table, which will be employee table 2, and then we will try to add some duplicate entries into it. Remember, we will not use the primary key here. So the code will be create table employee table 2, and everything will be same, which is from the previous table, which will be the employee ID, integer type, employee name, character type, this character type, pin code will be integer, and normally we include the primary key in this way. Primary key brackets open em. So this is the way how we add the primary key, but we are not going to add it since we want to know what happens if we enter data which also has the duplication of the primary key, right? So we will not give any primary key over here. Let's quickly run this. There you go. The new duplicated table of employee table has been created. Let's try to insert the same values with some duplication. There you go. I have pasted the command for inserting the values, and if you observe clearly at the end, I have repeated the values of Tony, Katie, Sama, June and Gloria. So these 5 will be the duplicate values, and also we are trying to enter the duplicated primary key. Since we did not declare the ID as the primary key, it will accept all these values. Let's quickly run this, and there you go. The values have been successfully entered into the table. Let's quickly see if we have the duplication. Select star from employee table Control enter. There you go. So you can see the duplicate values are also added onto the table. Now, how do you remove these duplications? Remember, we discussed the distinct method, which is the second one. So that happens to be the most simplest one. Let's see how it works. So here we will write a simple select command. Select distinct star from the employee table 2. Now this will give us the distinct values, right? But again, when you run this particular command, which is select star, you will have all the details back again, right? Our job is to eliminate them. So what we will do is we'll create a duplicate table. So let's name it as DUP table. So create table and duplicate table will be the name. Now quickly execute this command. And there you go. Now we have the data which we obtained from the distinct command is stored into the table named as duplicate table. Now let's quickly drop the employee table 2. Okay, the table has been successfully dropped. So when we run the same command once again, it says Simplilearn DB did not find any table by the name employee table 2. That means it's been eliminated. Now the next thing we need to do is rename it. So what we're trying to do is we are trying to use the alter table and we are trying to rename duplicate copy to employee table 2 so that we have the actual table here after eliminating the duplicated values. It's not dupe copy, it's actually dupe table. Right. There you go. Now let's execute this. Successfully done. Now if we execute this particular select command, you can see we have the cleaned data without any duplicate entries. This was one of the simplest ways of eliminating duplicates in a SQL table. Now let's try to get a step ahead and try to use some join commands and where commands and where conditions, and using those we will try to eliminate the duplications in a table. Now we are talking about a table which does have the primary key and the data will be duplicated. Let me explain you how. Now let us declare the primary key as employee ID. The key is EMP ID. Right now we do have a primary key. Now there is no way. Okay, let's try to create this. Before that, let's try to truncate employee table 2. So we can use the not drop table, we can use the truncate. So let's replace drop with truncate so that the data which we have in employee table will be removed. There you go. Now we will, or let's quickly drop the table because we are trying to create the new table, right? So let's create the new table. So Once we have executed the drop table command, the table has been successfully removed. Now let's try to create this particular table. Control Enter. There you go, the table got successfully created. Now let's try to duplicate the same entries. Remember, I'm not changing the primary key here. Now when I run this command, I will get an error which says primary key cannot be duplicated. So here you can see duplicate entry for 9 and you cannot have the duplicate entries, right? This is one way to avoid duplications. But what if someone comes up with a brilliant idea to replace the primary key? Now if I change the primary key as 17, 18, let's say we also have this data copied. Let's duplicate this. Right, this will be our 19 and this will be our 20. Now we have unique primary keys for all our data, and we also know there are some duplications. Let's try to execute this command and see the output. So somewhere something is not correct yet. Okay, this one. So Tony has been repeated, so we can have a different ID for Tony. Let's say we have Tony as 21. Try to execute the command once again. It should be clear now. Okay, it still has some duplication somewhere. Yes, it's right here. Let's keep this as 22. Okay, I think we made a lot of duplications somehow. Let's quickly take a look if all the major keywords are duplicated or not. So we copied from Gloria. So after Gloria, we will remove these. So Gloria, so we just make sure, we're trying to make sure that the primary keys are unique here. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20, 22. There you go. So now we believe that all the primary keys are unique. Let's try to run this command and see if we get the same error or not. No. So now all the data has been inserted into the duplicate table, which is employee table 2. And we also have some duplicate entries. Now, how would you recognize that we don't have any duplicates, or how would you recognize which data has been exactly duplicated, and how do you even remove it? Now the old distinct command is not going to work. Anyhow, let's see if it works by any chance. So when I try to run the distinct command, it will give me all 22 rows with all the duplicate entries, right? In this case, we can use the first method, which was the join and where condition method, right? Let's try to do that. So we are going to use the delete command, delete T1 from employee table to T1 inner join employee table 2 as T2. So we are declaring two different tables. So we are considering T1 as one table and T2 as the next or second table. So T1 and T2 are the copies of the same existing employee table 2, right? Now we are joining these two tables and we are having a where condition over here. So from table T1, we are going to eliminate table 1 from table 2, where we have an intersection and where we have the employee IDs greater than employee ID in employee. Okay, let's not confuse. So let's execute the command first. Okay, let's execute this to understand what I mean here. So here when we go a little down, you can see 14 for Tony, right? Actual employee ID of Tony is 9, but we have 14 for Tony. And Gloria, we have 18, 19, 20. And again, for Katie, we have 22. The actual number of Katie is 10, right? So now it will try to recognize the highest number of employee ID. So it will recognize the highest employee ID number and it will retain it, and rest all the numbers will be eliminated. So this is the first where condition, and we're also giving a string comparison function where SQL will try to identify if there is a similarity between the employee name of the first table and the employee name of the second table. And we know that when you give the string comparison operation, if it results in 0, it means the strings are equal. If it results in 1, it means the strings are not matching. Now that we understood the logic of this particular statement, let's try to execute it. So there you go. So we have executed the command. Now let's try to see what's left in the table. There you go. Now we should be having the usual 13 number of employees in our table. And you can see that the records are retained where the employee ID number is the highest. Remember, we had the number 10 as employee ID for Katie, and we have that over here. In case if you want the actual numbers to be placed however they were, you can make a small change to your command. All you need to do is keep this particular or change this particular greater than symbol to lower than symbol, and you will retain the actual numbers of the employee records. So that's how you can eliminate the duplicate entries in the table. And if you ask me, hey, only 2 conditions are enough, don't you think the pin code and we also have pin code and the address of the employees, don't you think that is also important? Yes, you can also do that. You can make some minor modifications to your code and try to include all those remaining things, and again you can do the same, right? Now let's try to eliminate the data in our table. Let's truncate it, and we should be having no data left in our table. And let's try to insert the duplicate entries once again. And okay, before that, let's try to do this particular execution. Remember, we tried to keep the employee ID. Let's try to execute that and try to print it, and we should be having the actual numbers over here, right, as expected. Now let's again truncate the data and try to compare the conditions, or we will be using the where condition and we'll have all the parameters included in our condition. Let's truncate the table, and now let's try to add the duplicate entries once again. There you go, we have all the duplicate entries entered. Now what we will be doing is we will be using the same command, but the only change will be the string comparison or the where condition, right? So you can keep this string comparison if you want, or if you can change that. Let me change that actually. So instead of this, we will use this particular command where we are trying to compare the employee ID. So let's keep the employee ID as lesser than, so that we have the actual employee ID numbers, and we are using an AND condition over here, so that this particular condition should be valid and the employee name should be equal to the employee name in T1 and T2. Yep. And the next one is, here we have the employee address. So the employee address in T1 and T2 should also be same, and pin code from both the tables should also be same. So what we are trying to compare here is we are trying to keep the employee ID with the least number or the least value, and the names of the employee should be same, the address of the employee should be same, and the pin code of the employee should be same. In that particular condition, you can try to delete the record. Let's try to execute this, and there you go, the command got executed. And now let's try to execute the select command, which should give us the final result. So here you go, Control Enter, and you have the data here. So now we have successfully eliminated all the duplicates by comparing the values in each and every single column, and we also have retained the original ID of each and every employee. Now that's how you try to eliminate duplicates in SQL tables. So at first, let's take a quick look on the syntax that we will be using for getting the like operator operation. Right, so it's really simple. So all you need to do is select star from table name. So instead of star, you can also give your selected columns here, but by default I'm using to select the entire table, right? And it can go with where clause. So after the table name, you will be given the where clause and the column name that you want to extract, and you will be using the like operator with the constraints. And I'm using the single quotes here, right? Because this particular like operation can be used upon string or varchar or character type data types, right? So we will represent that particular data type using single quote. Now that we are clear with the syntax, let's go to the practical mode, that is the SQL workbench or MySQL workbench, and execute the like operator command.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are on the MySQL workbench and we have some data or tables, and let's consider the employee name. So we have some text or varchar type of data type in the employee name as well as the employee department, right? Let's use that particular data, and here we have the command and select star from employee table 2, where we can edit the same command employee name like, and remember the single quotes, right? And we will be using the percentage operation here, right? We can give the full name, so we have Jennifer here, right? Jennifer, or let's remove Jennifer, and if somebody asks you, give me all the names which start with a J, right? In that particular situation, we will be using the modulus symbol or percentage symbol, right? Now what we will get is all the names that start with the alphabet J. And now let's say we want all the names that include a certain alphabet, let's say R, right? Then we can use the modulus symbol again. It can start with anything and it can end with anything, but it should have alphabet R. So this is how it works. So we have all the names which start or include the alphabet R in them, right? And that's how we can use the like operator in SQL. You can also use like operator in this way, where you can give the entire name. Let's say somebody asks you to get one single row which has the employee name as Peter, right? You can also do this in this way. There you go, you have Peter. If you're an aspiring data engineer looking for online training and certifications from the prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM should be your right choice. For more details, use the link in the description box below.
First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement, and then followed by the column names that we want to select. From, we have the table name, followed by the where condition, and next we have the group by clause, and here we include the column names. Finally we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company. Then we have the department to which each of these employees belong to. We have the city to which the employees belong to. And then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average_salary, which appears in the output. You can see here from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL workbench, where we will implement group by and solve specific problems.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so I am on my MySQL workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query, that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL_intro database. So I'll write use SQL_intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL_intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee_ID, which is the ID for each employee. I'll give my data type as integer, and I'll assign employee ID as my primary key. Next, I'll give employee_name, and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next, we have the date of join, and the data type will be date. We have the department column as well. This is going to be of varchar, and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees, and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad, and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information, and now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned and here are the department names. So we have sales, marketing, product, tech, IT, finance and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also. So you can round the decimal places, so I'll use a round function before the average function, and the round function takes 2 parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright. Now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma. Now I want the total salary, so I'll use the sum function and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly, we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next, we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 1, 2, 3, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay. Now suppose you want to find the revenue for both the product IDs 1 to 1 and let's say 1, 2, 3, since we have just 2 product IDs here. So for that you can use the select query. So I'll write select product ID. Next, I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally, I'll group it by product ID. Let's run it. There you go. So here you can see we have the 2 product IDs, 121 and 123, and here you can see the revenue that was generated from these 2 products. Alright. Now let's say we have to find the total profit that was made from both the products, 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these 2 values. Okay. Next, we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot sell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table, as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by c.product ID. Let's run this. There you go. So here you can see for product ID 121, we made a profit of $1,100, and for product ID 123, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees, we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees. Next we'll use the group by clause, and I want to group it by each department, and then I'm going to write my having clause. So in having clause, I'll use my condition that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function, and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees, group by department, and in the having clause I am going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000. This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay, so let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL.
Now, before we execute the actual code, let's take a quick peek on the syntax that we will be using today. Now, the syntax is completely similar to the regular syntax that we usually use. It will have the select keyword, parameters that you want to print in your table, the from keyword, and the table name which you're trying to access. The only difference is you will have a new keyword, that is the group by keyword, and based on a certain parameter. Right, now we would get back to the practical mode, that is the MySQL workbench, to understand the practicality of group by clause in a much better way.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we are on our SQL workbench. Now let's get access to our Simplilearn database. There you go. Now let's quickly take the look at the tables we have. We have two different tables. Now let's get access to our employee table. Now we have all the employee numbers, employee names, department, designation, salary, etc. Right? Let's say you wanted to know the average salary of all the employees, right? So that would be select, that is the AVG, average function of salary, close the bracket, from EMPLOYEE, right? Let's execute this. There you go. Now you have the average salary of the entire office. But what happens when your manager asks you to find the average of each and every department, average salary of the employees in each and every department? How would you do that? Right. Every organization has multiple departments, HR, development, testing, etc., etc. Right. Now, your manager wants the individual department's average salary. Then you can use this particular clause which says group by department. So the entire table will be categorized based on the departments, and it will be grouped on the basis of the department. And I'm also using the order by here, which we will discuss in the next session. But to give you a brief understanding of why we are using order by, let's say your manager asks you to find the department which has the highest average salary, right? Then you will be ordering the tables or ordering the rows based on the descending order of the salary. Now let's quickly execute this query and see the output. There you go. The query got successfully executed and we have the average salary of each and every department. It's how to find the second highest salary in SQL. So this particular type of questions will be most frequently asked in data analytics interview questions. So let's try to understand the syntax of how to find the not just second but any number of salaries given in a SQL table. Let's say your interviewer asked you to find the top third salary or top fourth salary. You can find that using the same syntax. So the syntax is something similar to this as shown now. But before we begin, if you are an aspiring data analyst, then I have the perfect course for you. We have the Professional Certificate Program in Data Analytics. Boost your career with this data analytics program in partnership with Purdue University and in collaboration with IBM, which features masterclasses and follows an applied learning model with real-time projects and business case studies. Now that we have a clear understanding of the PGP Data Analytics certification with Simplilearn in collaboration with IBM from Purdue University, we will get started with our tutorial for today's session. So here you can see select star. You can also use the specific columns you want, that is name and salary, but I'm selecting star, that is every single column in my table. That is select star from employee table, group by salary. So you'll be grouping by salary here, and order by salary descending. Since we wanted to find the highest, we will be choosing the descending order, that is increased number, that is the highest number to the lowest number. In case if your employer or if your interviewer asks you to find the lowest salary, then you will be using the ascending order, right? So since we are given the condition that we have to find the highest, we will use the descending order. Then limit n minus 1. Let's say you're supposed to find the fifth highest salary. Then the formula will be 5 minus 1 and the limit 1. That is, you just want one single row to be displayed on your output, right? So that's the reason we'll be giving limit as 1, right? So this is the simple syntax you will be following. Now let's quickly execute this on MySQL Workbench and try to get our results. Back to the Microsoft SQL Workbench. So now we are on the MySQL Workbench. Let's quickly use the database and get access to our all tables. Now we have access to the tables and the employee table which we were working on. So let's quickly have the show tables here, and we have employee and employee table too. We will be accessing the employee table which has the salary details. So there you go. We have Rakesh, Jack, Regina, etc. right? So here you can see Karan has the highest salary and the next second highest salary is Rakesh. So we need to fetch this particular column here, right? Since our expectation is to find the second highest salary, let's try to write the following code. That is select star from employee, group by salary, order by salary, descending order since we want highest salary, and the limit n minus 1, that is 2 minus 1, or you can also write as 1 comma 1, and done. Let's quickly execute this code, and there you go. Now let's say we want to find the third highest salary. So here n minus 1, 3 minus 1 is 2, and execute this, and there you go, you have Regina. So that's how you can extract second highest salary or any number of highest salary or the lowest salary based on the query changes you're doing. Let's say if you want to highest salary, then you should be using descending order. Let's say you want the lowest salary, you should be using the ascending order. So that's how you can extract the second highest salary from SQL tables. How to create views in SQL. And if you're an aspiring data analyst looking for online training and certification from prestigious universities and in collaboration with leading industry experts, then search no more. Simplilearn's professional certification program in data analytics from Purdue University in collaboration with IBM should be your right choice. For more details, use the link in the description box below. With that in mind, over to our PPT. Now, how do we create a view in Excel? So it's as simple as creating a new table. The syntax is as follows. You just need to add create a view and your customized view name as the statements. Now what are the statements? Statements usually have the statements of what you query, the query statements. For example, select star some data what you want to fetch from your table. Yes, I totally understand select might be a really short one, but sometimes you might have to add some where conditions, you might have to add some subqueries, and the entire query length might go up to 10 to 15 lines. Right, now you might not be able to execute that query for every single time. So if you create a view for that, and if you just select that particular view, and you get all the data. Now let's understand this more easily by going through a practical demonstration on MySQL. Now we are on the MySQL workbench. We are having a small database which is flights, and in that we have a table by the name flight data, and this is the data which we have added into a flight data. Right, let's run this and get the table. So here you have the information on your table about a few flights. You have the airline, date of journey, departure, destination, total stops, additional information, etc, etc. Right, now let's say if someone asked you to fetch a flight from Indigo which is completely non-stop. Control enter. Now you have this. Right, now you face this query for once. And what if someone asks you to get this data for 10 times a day? Maybe you have 10 clients who are asking for the same information. Would you write the same query 10 times? No, right? Similarly, here you have, let's say someone wanted to go to Delhi and they ask you to get the information for the flights which are going to Delhi. And someone asked for the flights which are going from Bangalore to Delhi. Right? Similarly, you have many of such things. So what would be helpful here? So let's say you add one more query which reads as create view. Now the customized view name could be anything. Let's say view Indigo nonstop. As your query. Right, let's quickly execute this query and it should create a new view for you. The new view is currently done. Similarly, let's try to create a new view again. Create a view. Let's name it view flights Delhi. Kolkata. And the Bangalore Delhi flights. Right, now you have the queries ready or the views ready. Now, all you have to do is just get the select statement star from the view name. This is simpler, right? Just control enter and you have the data over there. Now let's say somebody asks you to fetch the data for flights from Bangalore to Delhi. All you have to do is select star and you should be having the data. There you go, right? As simple as that. So that's how you can create a view in SQL. And in case if you wanted to drop it, let's say you don't need it anymore. So it's simple, just drop the view and the view name. Let's say you want to drop this particular view, paste it there and control enter. There you go. The view got successfully dropped. Now when you try to run this query, you will not get it. As simple as that.
Now I'm sure you must have heard about databases, but MongoDB is a popularly used not only SQL database. Now without further delay, let's begin and understand what exactly MongoDB is. So here's what's in store for you. First, we'll understand what MongoDB is. Then we'll understand why exactly MongoDB is used. Then we'll understand the characteristics of MongoDB. After that, we'll understand the working of MongoDB and how it functions. We'll also look at some of the commonly used applications of MongoDB. And finally, we'll look at the top companies that readily deploy MongoDB. So what exactly is MongoDB? It is a document-oriented NoSQL database. It was initially released in August 27, 2009. MongoDB replaces the concept of rows of conventional relational data models with something called documents. It offers developers the flexibility to work with evolving data models. Since it's document-based, MongoDB allows embedded documents, arrays, and represents complex hierarchical relationships using a single record. It is also schema-free, which means that the keys defined in the document are not fixed. As a result, massive data migrations can be ruled out. But you must be wondering, when there's something like SQL, why is NoSQL or MongoDB used? There are a few reasons why MongoDB is widely used. First up is flexibility. MongoDB's notion of documents that can contain sub-documents nested in complex hierarchies is really expressive and flexible. Flexible query model. A user can selectively index some part of a document or a query based on attribute values, regular expressions, or ranges. Next up is native aggregation. Native aggregation allows its users to extract and transform data from MongoDB and either load them in a new format or export it from MongoDB to other data sources. It makes it extremely compatible. Lastly, as mentioned earlier, the schema-free model. Now, applications get the power and responsibility to interpret different properties in different ways. Now that you know what MongoDB is and why exactly it's used, let's have a look at the characteristics of MongoDB. Firstly, it's a general-purpose database. Now, MongoDB can serve heterogeneous loads and multiple purposes within an application. Again, it has a flexible schema design. Document-oriented approaches with non-defined attributes that can be modified on the fly is a key contrast between MongoDB and any other relational database. Next up is scalability and load balancing. It's built to scale both vertically but most importantly horizontally. Using sharding, an architect can share load between different instances and achieve both read and write scalability. When it comes to load balancing, this happens automatically and transparently to the user by the shard balancer. Again, we have aggregation framework. Now, MongoDB offers an extract, transform, and load framework that eliminates the need for complex data pipelines. Native replication. Now, data will get replicated across a replica set without complicated setup. Security features. Both authentication and authorization are taken into account in MongoDB. Next up is JSON. Now, JSON is widely used across the web for front-end and API communication, and as such, it's easier when the database is also compatible with the same protocol. Lastly, we have MapReduce. Now again, MapReduce is an excellent tool to build data pipelines, and MongoDB uses MapReduce readily. Now let's quickly have a look at the working of MongoDB. Data is stored in documents with the help of key value pairs. Now, the data is stored in the BSON format. At the back end, MongoDB converts JSON data into a binary format known as BSON. MongoDB also makes provision for nested data. Now, all of these documents are stored in a collection. These collections hold multiple documents, and since MongoDB is schema-less, the documents in one collection need not be similar. Now again, these collections are stored in the entire MongoDB database. As mentioned earlier, MongoDB makes provision for nested data. This makes fetching of data extremely efficient when compared to other databases. Now you must be wondering where exactly MongoDB can be applied or used. So let me help you with that. Several areas of technologies use MongoDB as their DBMS currently. Some of them are Internet of Things, mobile applications, real-time analysis, personalization, catalog management, and content management. Now, all said and done, let's look at some of the companies that use MongoDB currently. Companies like Toyota, SAP, AstraZeneca, Adobe, Verizon, Cisco, Barclays, and Google, among others, readily deploy MongoDB as their database management system.
How to basically install MongoDB inside your MacBook. Many people today use MacBook, and there's a common question we receive like how to do the necessary setup. So it is very simple. First of all, you have to go back to your terminal. Okay, and inside this terminal, to just type the command name called brew space update. Number one. In case if you do not have a brew, I would like to request you that you first of all try to install the brew first. Okay, so make sure that you install the brew first, and in case if you do not have the success or the privilege available to you, so you first use sudo command before to make it possible. Okay, number one, so you have to just say brew update. Well, next step, once the brew update is happening, next step will be you have to use the same command called sudo. In case if you do not have a privilege, so you can use sudo space brew space install space MongoDB. So brew install MongoDB, that is the first command you need to type it. Once you say brew install MongoDB, the MongoDB will get installed in your system. It will take some time, depends on your internet speed. Once it is downloaded, then the next step what you have to do, you have to basically go back and create a new folder where, because since it is a NoSQL database, so it has to have some folder in which you have to provide the location where the data will get stored. So after downloading, you have to create a DB directory. This is where the Mongo files or the Mongo data files will actually stay. You can create this directory in the default location by running this call mkdir, okay, space -p and say /data/db. Are we clear? And also you have to make sure that you have the proper write permission, because in MacBook this is one of the very common challenge. Okay, you do not have a permission, so make sure that the data DB have a correct write permission. So in order to do this, you have to use this command called sudo space, okay, chown, and after that you have to say -r, and then you have to use id space -un, okay, and then you have to use /data/db. So like this, you'll be in position to give the permission. So it'll ask you the password post that, so you have to give the password, whatever the password of your MacBook it is, and that's it. And once it is ready, your MongoDB is all set. And to start this MongoDB or MongoDB, you have to start the MongoDB as a server. So if I just have to start, so you have to start with this MongoDB. Are we clear now? So MongoDB Then after I have to use -db path. After that, you have to give this enter sign /data/db. You hit enter and you can see now your Mongo database is now starting up and is now waiting for your Mongo client to get connected to. So you have to open the other terminal parallelly. I'm saying new tab, and here we are just typing Mongo, and there we go. You are connected successfully. Just type show DBS and you are done. So friends, it is a very simplified way of how the MongoDB can be installed into your MacBook. Very simplified steps I told you. There are other options are also available, but this seems to be more better.
You will have to navigate to the official MongoDB website. And here you can see software. So go ahead and click on community server under software. And you can see that the current version is 4.4.4 and the platform is Windows, and make sure that the package is MSI. Alright, now go ahead and press download. So this could take a while. Alright, so once it's downloaded, go ahead and install it. Now since it's already installed on my system, the installation process will be different, but you just need to follow the steps there and finally install it. So once you're done with the installation, you can go to your C drive, and here you can click on program files, and you can see that MongoDB is installed. And inside of it you have the server folder, and then you have the 4.4 folder, and then you have the bin folder. Right? So here you have the application, that is your Mongo and the MongoD applications. Both are executable files. Now the MongoD file or the application is the daemon process. Now this is the background process that makes sure you retrieve the data from the database, access the data. So it does all the background tasks. So after the installation, now you need to create a path to this file. By doing this, you don't have to always go to the bin folder and then execute the file. You can directly execute the file on your command prompt, right? So for that, let's just go to our environment variables. But before that, let's just copy this path, right? And here under the user variable section, click on path and say edit, and go ahead and just paste it, right? I've already pasted mine, so just go ahead and paste it and click on OK and say OK, right? So now you've created the path successfully. Now let's head to our command prompt and run the Mongo file. So here you can just directly type Mongo since the path has already been created. So just go ahead and say Mongo, and here you can see that your Mongo server has been generated, and with this you know that your MongoDB has been successfully installed and your server is up and running, right? So just for confirmation, let's see if there are any databases and how much space they've occupied. So you can right now just type show DBS, and when you click on it, it says admin, config and localhost, and all of it is 0. So with that, you have successfully installed MongoDB on your system and it's up and running.
Now we have moved to something called very important, that is installing MongoDB on Linux. This demo will show the steps to install MongoDB on Linux 64-bit. So what we're going to do, this command will download the MongoDB from the internet. So this command is going to untar the downloaded MongoDB which we have done. As we can see the bin. We're creating a directory called MongoDB. I'm just giving the path of the MongoDB to the bash RC file so that I can execute MongoDB bin from wherever I want. It's like environment variable setting the way we do for Java, for .NET. In Windows, we have environment variable. Similarly, in Linux, we have the bash RC file. So that is how the installation will happen of MongoDB on the Linux system. And now we will see how the MongoDB gets installed on the Windows. So this is something which, again, I would really want all of you to really focus on. It's again simple, the same way as we did in Linux. So what we do is, so we have MongoDB installation going on. So what I do, okay. So I'm again talking about Windows and would recommend if all of you also follow the same. So first step is download Mongo. You will get some .zip version. Second step, or rename it as MongoDB. So again, I'm telling you the scenarios so that everyone can go along. And place it under C. Place it under C. You can place it anywhere. Again, for better let us keep it under C. So now I'm assuming all of you have your MongoDB under. I'm assuming your MongoDB will be over here. This will be a folder. Inside this, you should be able to see bin now. And the bin should have all of the different commands. Now what I would recommend is, instead of just double click in MongoDB, open a command prompt. Open a command prompt. Go to C MongoDB bin. Go to this path, up till the bin, and now when you are in the bin, type MongoD and put an enter. It means you're saying that start the Mongo database instance. You should see on the screen, waiting for connections to open on the port 27017. This is what you should see on the command prompt. Fifth step, open another command prompt. Go to C MongoDB and type Mongo and put an enter. Now, what you should see in the your current command prompt should say connected to test, and your previous command prompt, that is on the step 4, should now say one connection open. Okay, so this is what your scenario should be. So please, all of you, follow these steps.
If you're an aspiring data engineer looking for online training and certifications from the prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data engineering from Purdue University in collaboration with IBM should be your right choice. For more details, use the link in the description box below.
MongoDB is a document-based database. The basic idea behind shifting from relational data model to a new data model is to replace the concept of a row with a flexible model, the document. The document-based approach allows embedded documents, arrays, and represents a complex hierarchical relationship using a single record. This is how developers using object-oriented languages want to represent their data. MongoDB is schema-free. The keys used in documents are not predefined or fixed. Without a fixed schema, massive data migrations have become unnecessary. While migrating data to MongoDB, any issues of new or missing keys can be resolved at the application level rather than changing the schema in the database. This offers developers the flexibility of working with evolving data models. The table given on the screen depicts the various SQL terminology and concepts, and the corresponding MongoDB terminology and concepts. In MongoDB, the table and view structure is known as collection. Typically, these collections group documents that are structurally or conceptually similar. MongoDB allows embedding a related document to one another. These documents are used to query related data. The data for a table in MongoDB are distributed among different shards, which is similar to the concept of partition in relational database management systems, or DBMS. After grouping structurally similar documents into collection, MongoDB groups different collections into databases. For instance, a single instance of MongoDB is capable of hosting multiple independent databases. Ideally, you should store data related to a single application at one database. You need separate databases when storing multiple application or users' data on the same MongoDB server. The data model in MongoDB is document-based. Although documents provide rich structure, they need not conform to any pre-specified schema. In a relational database, rows are stored in a table, and each table has a strictly defined schema that specifies the permitted types and columns. If a row in a table requires an extra field, the entire table needs to be altered. MongoDB, on the other hand, groups documents into collections that do not follow any schema. Each individual document in a collection can have a completely independent structure. In practice, documents in a collection are relatively uniform. For example, if you are creating a collection review_comments for storing review comments given by the customer, then every document in this collection will have fields such as title, tags, comments, and so on. The lack of schema offers many advantages. First, since structure is defined by the application code, not the database, this speeds up initial application development when the schema tends to change frequently. Second, a schemaless model lets you represent data with variable properties. Compared to RDBMS, such as MySQL, which supports two-phase commit, MongoDB only supports a single-phase commit at each document level. A write operation in a single document is considered atomic in MongoDB, even if the operation alters multiple embedded documents. However, the entire operation is not atomic, and other operations may interleave. Some of the key features of MongoDB are as follows. Ad hoc queries. MongoDB allows performing of search functions by field, range queries, and regular expression searches. Queries can return specific document fields and may include user-defined JavaScript functions. Querying. For document retrieval, MongoDB uses rich query language. It also allows you to write any complex condition to retrieve documents. Fast in-place updates. MongoDB allows you to choose write semantics, enable journaling, and thus control the speed and durability. All writes are sent across a Transmission Control Protocol, or TCP socket, and do not require a database response. To get a response, use the special safe mode of the drivers and perform a write. This generates a response acknowledging the receipt of the write with no errors. Server-side JavaScript execution. MongoDB uses JavaScript in queries and aggregation functions such as MapReduce, which are sent to the database for execution. Capped collections. Capped collections are fixed-size collections supported by MongoDB. These collections maintain insertion order, and once the specified size has been reached, behaves like a circular queue. MongoDB supports other data types while retaining JSON's essential key-value pair characteristic. How values of each type are represented depends on the language used. Following is a list of the commonly supported data types. Null is used to represent both a null value and a non-existent field. For example, field X has null value. Undefined is used in documents. JavaScript has distinct types for null and undefined. For example, field X is undefined. Boolean is used to represent true and false values. For example, field X is a Boolean variable whose value is true. 32-bit integer cannot be represented on the shell. JavaScript supports only 64-bit floating point numbers. Hence, 32-bit integers will be converted to 64-bit. 64-bit integer. The shell cannot represent these and will display them using a special embedded document. 64-bit floating point number. All numbers in the shell must be of this type. Here are a few more data types supported by MongoDB. Maximum value. BSON contains a special data type that represents the largest possible value. The shell does not support this type. Minimum value. BSON contains a special data type that represents the smallest possible value. The shell does not support this type. Object ID. Object ID data type is unique, fast to generate, and ordered. These consist of 12 bytes where the first 4 bytes represent the object ID creation time. String. BSON strings are UTF-8 compliant. Typically, when serializing and deserializing BSON, programming languages convert language strings to UTF-8 format. This allows easy storing of international characters in BSON strings. Symbol. Symbols are not supported by the shell. When the shell gets a symbol from the database, it converts it into a string. Timestamps. BSON offers a special timestamp for internal MongoDB use that is not associated with the regular date type. Note that within a single MongoDB instance, timestamp values are always unique. Date. Date in BSON is a 64-bit integer that denotes the number of milliseconds since the Unix epoch. It can represent a date range of about 290 million years into the past and future. Regular expression. Documents contain JavaScript's regular expression syntax. For example, X is the field whose value contain substring Simplilearn. Following are some more data types supported by MongoDB. Code. Documents can contain JavaScript code. For example, logic inside function. Binary data. It is a string of arbitrary bytes. It cannot be manipulated from the shell. Array. Sets or lists of values can be represented as arrays. Courses is the field whose value is an array. This array holds 3 elements, PMP, Cloud, and MongoDB. Embedded document. Documents can contain entire documents, embedded as values in a parent document. For example, course_duration is the embedded document which has field name MongoDB. The value for this field is 24 hours. The core database server of MongoDB can be run as an executable process called MongoD or MongoDB.exe on Windows. The MongoD process receives a command to run the MongoDB server over a network socket through a custom binary protocol. The data files for a MongoD process are stored by default in the directory /data/db. You can run a MongoD process in several modes. The most common mode is the replica set. Typically, replica set configurations comprise 2 replicas and an arbiter process that reside on a third server. The auto-sharding architecture of MongoDB consists of MongoD processes configured as per-shard replica sets. It also consists special metadata servers called config servers. In addition, MongoS, a separate routing server, is used to send requests to the appropriate shard. MongoS queries from the application layer and locates the data in the sharded cluster to complete these operations. A MongoS instance is identical to any MongoDB instance. MongoDB tools consists of the following: JavaScript shell, database drivers, and command line tools. The JavaScript shell. The command shell in MongoDB is a JavaScript-based tool. It is used to administer the database and manipulate data. A Mongo executable loads the shell and connects it to a specified MongoD process. In addition to inserting and querying data, the shell allows you to run administrative commands. Database drivers. The MongoDB drivers are easy to use. It provides an application program interface, or API, that matches the syntax of the language used while maintaining uniform interfaces across languages. Tengen, a company behind MongoDB, supports drivers for C, C++, C#, Erlang, Haskell, Java, Perl, PHP, Python, Scala, and Ruby. Command line tools. MongoDB contains the following command line utilities. MongoDump and MongoRestore are standard utilities that help back up and restore a database. MongoDump can save the data and the BSON format of MongoDB, and thus is used for backups only. This tool is used for hot backups and can be restored with MongoRestore easily. MongoExport and MongoImport are used to export and import JSON, separated value, or CSV, and tab separated value, or TSV data. These tools help you get data in widely supported formats. You can use MongoImport for initial imports of large data sets. However, you need to adjust the data models for best results. In such a case, you can use a custom script to easily import the data through one of the drivers. MongoSniff is a wire sniffing tool used for viewing operations sent to the database. This tool translates the BSON that is transmitted to human-readable shell statements. MongoStat is similar to IOStat. MongoStat provides helpful statistics, including the number of operations per second. For example, inserts, queries, updates, deletes, and so on. It also provides information such as the amount of virtual memory allocated and the number of connections to the server. This demo will show the steps to install MongoDB on Linux. In this demo, you will learn how to install MongoDB on Linux machine. First, download the latest MongoDB binary for Linux platform. To download, type the command shown on the screen. After the MongoDB binary is downloaded, untar it by executing the command shown on the screen. Next, create a directory /MongoDB by executing the command make directory -p/MongoDB. Next, copy the untarred directory by executing command shown on the screen. To run MongoDB from anywhere in Linux, you need to add MongoDB installation path in the .bashrc file. To do so, execute the command vi /root/.bashrc. Next, type the two commands given on the screen. Note that your .bashrc file location may be different based on your username and profile. Reload the environment variable by executing the command source/root/.bashrc. Next, execute the command echo $MongoDB_home to verify whether the environment variable MongoDB_home has been set or not. This concludes the demo on installing MongoDB on Linux computer. This demo will show the steps to install MongoDB on a Windows computer. In this demo, you will learn how to install MongoDB on a Windows computer. MongoDB for Windows runs only on Windows Server 2008 R2, Windows Vista, or the later versions. The .msi installer includes all software dependencies. If you have an older version of MongoDB installed on your computer, the .msi file will automatically upgrade it to the latest version. To install, first go to the site given on the screen. In the Download and Run MongoDB page, scroll down and click Download to MSI, and then click Run. Once the MSI file is downloaded, the installation wizard opens automatically. Next, follow the default options on the wizard to install MongoDB. This concludes the demo on installing MongoDB on a Windows computer. This demo will show the steps to start MongoDB on Linux. In this demo, you will learn how to run the MongoD server and the Mongo shell on Linux. To start the MongoD server, type MongoD in the command prompt. The MongoD script file is in the /bin directory of your MongoD home path. Once MongoD server starts running, open another terminal. To open the Mongo shell, type Mongo in the second terminal. In the Mongo shell, perform the MongoDB insert operation by executing the command given on the screen. To check whether document was inserted, use the find method on courses collection. This concludes the demo on starting MongoDB on Linux. This demo will show the steps to start MongoDB on Windows. In this demo, you will learn how to run MongoD server and Mongo shell on Windows machine. To begin, navigate to the path C:/program files/ MongoDB/ server/3.0/bin. To start the MongoD server, double-click MongoD.exe. Once the MongoD server starts running, open another command prompt to open the MongoD shell. To open the Mongo shell, double-click the mongo.exe in the same directory. To perform the insert operation in the Mongo shell, execute the command given on the screen. To check whether the document was inserted, execute the command db.courses.find. This concludes the demo on starting MongoDB on Windows.
Something which used to happen earlier, and it gave way to something called replica sets. So the master-slave replication is the oldest mode of replication that MongoDB supports. In the earlier versions of MongoDB, the master-slave replication was used for failover, backup, and the read scaling. In the newer versions, it is replaced by replica sets for the most number of use cases. Here you can see there is a master and there are slaves attached to that. So replica sets are recommended for new production deployments to replicate data in a faster rather than a master-slave architecture. So again, how does a replica set in MongoDB works? So a replica set consists of a group of MongoDB instances that we just saw that host the same data set. That again we have saw. The replica set functions as follow. The primary MongoDB receives all the write operations, and the secondary MongoDB replicates the operations from the primary. This is something which Sandeep would have seen in a live working on his replica set. The primary node receives the write operations from the clients. The primary logs any changes or updates to its datasets in its oplog. The secondaries replicate the oplog of the primary and apply all the operations to their datasets. So replica set in MongoDB. An extra MongoDB instance can be added to a replica set to act as an arbiter. So what is an arbiter node? So this is specifically added to the replica set so that the total number of instances we can have can be odd, so that if in case the primary goes down, we can have a majority if an election takes place. So following are some of the characteristics of an arbiter. So arbiters do not maintain a data set. Arbiter is the node which just participate in an election to select the primary node. So the only purpose of it is to take part in the election. It doesn't even store the data. So again, arbiters do not require dedicated hardware. Again, it can just work as a command prompt, as we have done in our systems. Secondary members in a replica set asynchronously apply operations from the primary. Important point to be noted over here is asynchronously. It's a lazy write. These replica sets can function without some secondary members. As a result, all secondary members may not return the updated data to the clients. So again, when I told Sandeep that you make a write to the primary or an update to the primary and see the data back in the secondary. So you guys would have seen again that you are not able to see the data over there in the secondary. It'll come after some time because again it's a lazy write to the secondary. So a primary can convert to a secondary or vice versa. However, an arbiter remains changed. Automatic failover. So this is something which talks about the replication in detail, and what it talks about is when the primary node of a replica set stops communicating with other members for more than 10 seconds, another member is selected as the new primary. Selection happens through an election process. The secondary node that gets majority of the votes becomes the primary. A replica set supports application needs in the following ways. Again, deploying a replica set in multiple data centers, manipulating primary election by adjusting the priority of the members. So that's what again, when we initiate an instance, I can also, when I specify the config, again ID the members. Along with that, I can specify the priority as well. That if the priority of the guy will be more, I can ensure that whether the secondary will be able to become a primary ever or not. Supporting dedicated members for functions such as reporting, disaster recovery, or backup. So again, we can see in the diagram that the primary goes down. What happens is election for a new primary happens, and again we see that the new primary is elected. One of the secondary becomes the primary, and the other secondary just follows what the primary says. Again, replica set members. A replica set can also have an arbiter. Arbiters do not replicate or store data, but again play a crucial role in selecting a secondary to take the place of a primary when the primary becomes unavailable. A typical replica set contains a primary, secondary, and an arbiter. So again, what we see is we have a primary node, we have a secondary node, and we have an arbiter. And you can see there is a heartbeat going constantly between all the nodes. Again, this heartbeat is on the similar lines, what heartbeat we see in Hadoop. In Hadoop, we see all the secondaries, that is the data nodes, share a heartbeat with the name node. So again, like this, all the nodes over here in MongoDB as well share a heartbeat among themselves. A replica set in MongoDB version 3.0 can have maximum 50 members with only 7 members capable of voting in the election. So again, now we are specifically talking about who are priority 0 replica set members. Again, when we set a member a priority of 0, what will happen? That will be a secondary which can never become a primary. So again, a priority 0 member is a secondary member that cannot become the primary. The characteristics of a priority 0 are: it cannot trigger any election, it can maintain dataset copies, accept and perform read operations, and again choose in electing a primary. So again, he can vote an election, though he cannot trigger an election. So by configuring a priority 0 member, you can prevent secondaries from becoming the primary. In a 3-member replica set, one data center hosts both the primary and the secondary, and a second data center hosts one priority 0 member. So again, I've just kept one copy of the data in some other data center just to ensure if the full data center goes off, I still have some data with me safe in some other data center. A priority 0 member acts as a backup and can immediately replace an unavailable member in a replica set, because again it has the data. So always we recommend that we have a priority 0 replica set member as well in our replica set. Now we have something called hidden replica set members. Again, hidden members are those which are not seen to the client. What again that means? Hidden members of a replica set are invisible to the client applications. The characteristics of a hidden member are: they store a copy of the primary's data. They are priority 0 members. Again, they mean the moment you see priority 0, the main thing which should come to your mind is it's a secondary and it cannot ever become a primary. They are priority 0 members, can elect a primary but cannot actually become a primary or replace a primary. They are not given appropriate read and write rights. They can be used for dedicated functions like reporting and the backup. So there's something you see, there is a primary, there is secondary, secondary, and again there is a secondary guy with priority is 0. Then there are some replica sets. Again, an important thing which is asked in the interviews quite often. What are delayed replica set members? Again, I can even set some members in a replica set with a delayed. I can specify that you start copying the data from the primary after these particular minutes. So those are called delayed replica set members. So again, delayed replica set members are secondaries that copy data from the primary node's oplog file after certain interval or delay. Delayed replica set members reflect a previous version or delayed state of the stored data set. It's like I create a backup of the data after every some t hours. What happens is, in case of a failure or something, I can again make the system come back from whatever time it was earlier. So delayed replica set members are secondaries that copy data from the primary node's oplog file after certain interval delay. Delayed replica set members reflect the previous version or delayed state of the stored data set. So again, what I was saying to you guys was very importantly, they are basically used so that we can checkpoint some data, so that if in case of some failure, I can still bring the data back to the system to the place it was earlier. So delayed members perform a role backup or on a historical snapshot of the dataset. They help manage various human errors and recover from errors such as unsuccessful application upgrade and drop databases and collections. The characteristics of a delayed member are as follows. It must be a priority 0 member. It must be hidden and not be visible to applications. It again must participate in electing a primary. Now again we can see over here what is this. So what we're talking about is you can configure a delayed secondary member with the seconds given below. So again, delayed secondary member, it again has to have a priority value of 0, which again means that it is a secondary which cannot ever become a primary. Hidden value is true, it means it will be hidden. And again, slave delay value means again how much seconds you want the system to wait till it makes a copy of the oplog. To set an 1 hour delay, issue the operations given below. Again, you can see over here what we are setting is we are setting a configuration. So config is equal to rs.conf, and again what we give over here is config.members 0.priority we are giving is 0. Again members. So again please see that what you see over here, the members you see over here is the array which you had in your configuration. So the first member, his priority I'm setting is 0, his hidden I'm setting is true, his slave delay I'm setting is 3600, and again after I've made some configuration changes, I can reconfigure it.
First, let's look at what exactly is MongoDB. Now, as you all know, MongoDB is an open source, document-oriented NoSQL database. It is document-based, which means that the data stored is represented in a hierarchical relationship using a single record. And also, MongoDB is schema-free, which means there's no set schema to define how the data is being stored in the database. This causes lesser data migrations. But what exactly is MySQL then? Now, MySQL is an open source relational database management system. Unlike MongoDB, which is document-oriented, MySQL is a relational database system. Now, this uses something called as a structured query language, and this is used to access data which is stored in the form of rows and columns. Now, as mentioned earlier, data here is stored in the form of tables with rows and columns, and each data field comes with an index representing the data in the table. And SQL is developed and maintained by Oracle. So then what exactly sets them apart? So in the coming section, we'll look at some of the differences between MySQL and MongoDB depending on certain features. First up is the data structure. Now, MySQL requires you to define your tables and columns before you can store anything. And every row in a table must have the same columns. In MongoDB, you just drop the data in these documents. Also, the data in the MongoDB database is stored in a binary format called as BSON. Next up, we have schema. Now, as discussed earlier, MySQL requires a set schema to define the tables in the database. Now, the database administrator is requested to define a schema which defines how the different tables are being stored in the database. Now, this schema is crucial in case of MySQL. On the other hand, MongoDB doesn't require a prior definition of a schema. Next up is languages. MySQL uses the structured query language to perform actions on the database. It is used to retrieve data, add data, update, create a new dataset, etc. In case of MongoDB, it supports a JSON query language to work with data. Next up is foreign keys. Now, MySQL supports the usage of foreign keys. Now, if you don't know what exactly a foreign key is, then SQL uses foreign keys to link one table to another. Now, these foreign keys make data retrieval easy, especially when there are multiple tables interlinked with one another. In case of MongoDB, there's no support for foreign keys. Next up is replication. Now, MySQL supports the master-slave and the master-master replication. In this setup, data set from one master database server can be copied to other servers. In case of MongoDB, it uses something called as sharding. Now, sharding allows partitioning of data across multiple servers using a shard key. Don't worry if you're not able to understand these concepts well. In the coming videos, we'll explain these concepts in detail. Next up is scalability. Now, SQL database can be scaled vertically, while MongoDB can be scaled both vertically and horizontally. Now, horizontal scaling means scaling by adding more machines to your pool of resources, while vertical scaling refers to scaling by adding more power, like, for example, CPU or RAM. Moving ahead, let's look at performance. Now, MySQL is optimized for high-performance joins across multiple tables, while MongoDB is optimized for write performance. Talking about community support, some of the popular GitHub repositories on MySQL currently are mysql.js/mysql, and then there's MySQL Server. And at the time of writing, there were about 222,000 repositories on GitHub with 7 million commits for MySQL. In case of MongoDB, few popular GitHub repositories are MongoDB/Mongo and Doctrine/MongoDB. And at the time of writing, there were about 177,000 repositories with about 923,000 commits. According to Google Trends, MySQL is largely used compared to MongoDB. So now the question arises, which one should you choose? Well, if your application requires multi-row transactions, like for example an accounting system, then a relational database would be more ideal. But if you're using MongoDB, then it is more suitable for real-time analytics, content management, Internet of Things, mobile applications, and so on. Also, MySQL is a great choice if you have structured data and need a traditional relational database. In case of MongoDB, It is an ideal choice if you have an unstructured set of data. So you could pick your choice. And if you're partial towards one DBMS, let us know in the comment section below as to why you like that particular DBMS.
And with that, we have reached the end of this session on the entire SQL and MongoDB basics full course. Should you need any assistance based on PPT, project code, or any other resources used in this session, please let us know in the comment section below, and our team of experts would be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, keep learning, and get ahead. Stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.